Good morning, everybody. We will give folks just another minute or two to trickle in. Right off the top here, though, for those of you who have joined us, just want to welcome you to day 2 of our Adapting Restoration for a Changing Climate Symposium. And just a few housekeeping things as people continue to join. As you've noticed, you're automatically muted with your webcam off. While we do have the chat open for more comments or conversation with colleagues, for questions that are directed towards our speakers and panelists, please direct those to the Q&A function in Zoom, which you can find at the bottom of your screen. If you have any technical issues, you can email engage@deltacouncil.ca.gov or call or text the number there, 916-902-6460. And with that, I think we can transition to the next slide. We went over all this as a group yesterday, but we just wanted to remind you really briefly before we jump in. As I mentioned, Zoom chat for comments and conversations, Zoom Q&A for more directed questions during session panels. We also have a mural, which is an online engagement tool that is set up across sessions to be able to collect comments and questions. We are transferring questions and comments from Zoom onto there, but we also encourage you to interact directly with the mural if you feel comfortable doing that. Jenica just put a link in the chat to that. And for that mural as well, if you're not familiar with the platform and do want to take a look, there's a series of instructions on the left-hand side of the mural, and you sort of navigate by dragging it around. So please use the platform you prefer. Next slide. So building off of the 3 sessions we had yesterday, we're, again, just really excited about day 2 here, and just wanted to give you a quick rundown of our schedule before we launch into our first session. So from 9 a.m. to 10:40 today, we'll be thinking about linking long-term perspectives across the estuary and its watershed. For those of you who were here yesterday, you know that a theme of long-term thinking over longer planning horizons is a major theme of what we've asked our speakers and panelists to think about. So this will very much bring that home at a very large landscape scale. We'll have a break from 10:40 to 10:50, after which we will start our Visioning the Future panel on permitting, planning, and implementing restoration with speakers from a variety of perspectives, talking about the pieces of the system they work on and then engaging in conversation. And then from that, we'll roll directly into our closing panel, Moving Forward Under Uncertainty, which will be a recap of the symposium as well as an open conversation with speakers and moderators. Our morning session this morning is moderated by John Calloway, who you'll hear from soon. Our second session is moderated by Letitia Grenier, and our third session is moderated by Dr. Laura Larson, who is our lead scientist here at the Delta Science Program. So with that, I will thank our moderators, panelists, and speakers in advance and hand it over to John to get us started.
Great, Dylan. Thank you very much. And if you could put up the slides for our session, that would be great. Welcome again to day 2 of the session, as to echo Dylan's welcome. Some of the themes I heard from the first day were issues around complexity, ecosystem benefits and services, challenges of restoration, resiliency, partnerships, public engagement, inclusivity, Indigenous local knowledge, traditional ecological knowledge, as well as the urgency to address these issues and seize the moment, but lots of opportunities to do that with interest in climate change and new policies like the 30 by 30 initiative. So we'll try to build on some of those themes today with the next slide. So our session, as Dylan said, is linking long-term perspectives across the San Francisco estuary and its watershed. And I'm John Calloway. I'm from the Environmental Science Department at University of San Francisco, where I coordinate our master's program in environmental management. I did have the good fortune to serve as the Delta lead scientist for 3 years. And actually symposiums like this were one of the real highlights of working there and bringing together a wide range of perspectives on some of the real challenging issues for the Delta and the watershed. So next slide. So for this first session, I'm just going to give a very brief overview, and I will try to be brief so that we have maximum time for discussion with the panel. As Dylan said, we've asked speakers to address restoration around long-term time horizons, thinking not just about today's issues, but moving out to 20, 50, and 100 years ahead, and also to consider how how we address these issues across the entire watershed. Embracing the issues across the bay and the estuary and the bay and the delta, and thinking of the estuary as a single ecosystem is definitely something that's near and dear to me. And many people have been pushing on that, but this morning we're actually going to think even beyond the estuary and think across the entire watershed. So we have some challenging issues to really address. So next slide. So in addressing these issues, connectivity is right at the center of the discussion that we'll have this morning. And you'll see that this morning's panelists will address connectivity in a variety of ways. Obviously, water is right at the center of it, as that is what drives the entire ecosystem. But sediment, the water interacts with the landscape and moves sediment, and that sediment is essential for aquatic and wetland ecosystems throughout the watershed. Carbon from primary productivity is also a critical currency. Along with mineral sediments, organic carbon builds wetland ecosystems throughout the watershed, from mountain meadows to tidal marshes. And it's also the energy, that carbon is the energy that supports the food web, something that is in short supply for many organisms at the lower end of the watershed. And of course, organisms are also essential as they move throughout the watershed and are the focus of much of our management efforts. But linked to these issues of connectivity and continuity is the need to embrace variability and uncertainty that's inherent in ecosystem management and that grows with climate change. And these issues of variability and uncertainty link directly to adaptive management, something that is central to the Stewardship Council and the science program's approach to management. So next slide. So, if connectivity is really critical to these issues along the watershed, it's doubly important in terms of restoration issues. With restoration, we're almost always dealing with fragmented ecosystems and trying to restore connections, whether that's the vertical connections up and down the estuary or the lateral connectivity from the river to the adjacent floodplains and tidal marshes. Just as in other sessions, speakers will emphasize process-based restoration, working with the natural dynamics and energy within ecosystems across the watershed and using that within restoration. And related to this is just thinking about an ecosystem focus, reconnecting the physical and biological processes as water interacts with the landscape to create and modify the geomorphology of these systems. It's also important to emphasize that when we talk about restoration, we aren't thinking about going back in time, but managing forward towards ecosystems that will be resilient to upcoming variability with things like functional flows, surrogate marshes, and other things that you'll hear about from our panelists. Next slide. So if connectivity is doubly important for restoration, I'd say it's triply important for climate change. Organisms are already responding to climate change with shifts in their distributions up and down the watershed and shifts in their behavior and other interactions. But stresses and disturbances like drought and floods or fire are going to become more and more frequent and intense, and connectivity is essential to providing the resiliency for organisms to respond to these changes. And just as yesterday, you will hear a lot about resiliency in this morning's presentations. Next slide. So we have 5 very informative presentations packed into 10 minutes each to start the session. We've set them up so that we'll start at the top of the watershed and move down towards the ocean. And as I mentioned, the presentations will consider restoration and management from a variety of perspectives of water, sediment, organisms, carbon, and more. So first we'll hear from Amy Murrell about headwaters and mountain meadows. Sarah Yarnell will move us into the rivers with a discussion of functional flows. Jacob Katz will give us a tour of floodplain restoration. Scott Dusterhoff will bring us into the estuary to discuss sediment issues and wetlands. And Lisa Marie Wyndham Myers will highlight the importance of carbon dynamics for wetlands in the estuary and throughout the watershed. Next slide. So as I said, they've packed an enormous amount of information into their 10-minute presentations. That will be followed by some initial discussion within the panel. And then there will be lots of times for questions. So as Dylan said, we encourage you to put your questions into the Q&A or onto the mural board, just as you did yesterday. And we look forward to those questions and the discussion that we'll have around those. So that's all I have. And if we could queue up the first presentation, which, as I mentioned, our first presentation is by Amy Merrill from American Rivers, and she'll be talking about headwater issues and mountain meadows.
Hi, thanks for tuning in. My name's Amy Merrill, and I'm the interim director for the California program with American Rivers. In our program, we work to restore and protect California's rivers and waters from the Sierras to the sea. So we're super focused on these watersheds and how they and all of us are dealing with climate change in real time. And we've all seen what climate change is delivering. It's delivering reduced snowpack. We're looking at 60% reduction in our state's water bank, which is the snow, by the end of the century, with little to no snow below 6,000 feet. We're having hotter days, hotter nights, longer snow-free seasons that dry out the vegetation and are really drying out the soils and making them very thirsty. There's vacillations from drought to deluge, with more concentrated runoff and higher treacherous peak flows. We're also experiencing different kinds of fires, which can and should be our friend, but now the system is out of whack, and we're having crown fires that are casting embers far downwind, making that fire move fast and leaving behind square miles of slow to recover and charred landscapes. How did we get here? Well, short-sightedness, lack of understanding of the new land by the European settlers, and a touch of arrogance. By the mid-19th century, Western settlers ended thousands of years of sustainable fire management that were practiced by the indigenous people, replacing this with a zero tolerance for fire, Smokey the Bear policy started in 1910. And that has created really dense forests with a lot of fir species that are intolerant to fire. And those high density forests create unhealthy, thirsty trees. There is the same amount of water for many more trees that are now vulnerable to disease and insect outbreak, leaving millions of dead trees, dry, flammable trees now in our forests or up and down our mountain range. Also in the mid-19th century came a quick uptick in sheep and cattle grazing to support the booming gold miners, leaving nary a blade left in some of the meadows, along with road and railroad construction, among other things, that degraded these same meadows by straightening the channels and creating incised channels that drop the groundwater down below the plant's rooting zone. So hydraulic mining is another thing that happened that didn't help, creating small mountains of rock tailings up and down miles of river reaches in our mountains, and leaving a legacy of mercury behind in both the rivers and that's now caught behind our dams. So, wow, what a hand we've been dealt. But we can do this. Nature comes back if she's given just a half a chance. Our first thing that we have to do, of course, is to really reduce our fossil fuel use, convert to sustainable energy sources, and really we all need to use less energy and less stuff. Second, we can try to resist the effects of climate change. We can pull up the conifers that are encroaching in the meadows. We can put out the fires. We can try and hold back the increasing peak flows. But really, we can probably do better. Let's work with the natural solutions that have been staring at us for 200 years. Let's work with the natural systems and the processes to increase resilience in our watershed to the vagaries and extremes of climate change. What does that mean? Well, in the Sacramento Sierra headwaters, American Rivers is taking an integrated watershed approach, thinking of the whole system that supports our rivers. We all know, for example, that ecological fuels treatment to cut from below, smaller stem trees, removing and reducing the ladder fuels and pulling out the ground fuels, that works. It's best if it's followed by a prescribed fire wherever possible. This kind of treatment brings the flames down from the canopy to the ground where the negative impacts are lower, and the result can be a healthier forest. American Rivers is piloting a prioritization tool to identify where fuels treatments and prescribed fire can best be applied to protect rivers, because we know that rivers bear the brunt of the sediment and melted man-made materials that flow down from those burned areas. This tool that we're piloting now was put together by a UC Santa Barbara Bren School group of master's students supported by American Rivers. So we're excited to see that happening, and we're working now with a couple of institutions in the Sierras. We're also on this project and others, we're working with private landowners, tribes, and the Forest Service to increase the capacity and open up institutional or process bottlenecks to help bring strategic prescribed burn and fuels management to scale. Similarly, we're looking at strategic logging road closure and restoration of those lands to reduce the sediment inputs that they generate into the channels. So reducing impacts of roads and being strategic about targeting areas to contain or slow the spread of extreme fires in our watersheds with fuels management, prescribed burns, and road recovery is an important way to build resilience back into our headwaters. Another way to restore and support the mountain's natural infrastructure is to restore that natural infrastructure, which is the Mountain Meadows. American Rivers has long been an advocate for healthy mountain meadows. Healthy meadows are lovely places to be. They're biodiversity hotspots. Even though they cover just 2% of the Sierra Nevada region, meadows support 38 times more native plant species than their surrounding upland forests, and are the single most important Sierran habitat for birds, native trout, and amphibians. With over 60% of these meadows degraded from a long history of overgrazing and channelization, like I mentioned before, these meadows are not providing the resilience to drought that they could be if we restored them to their fully functioning conditions. For example, about 5 years ago, American Rivers led a study demonstrating how restoring a degraded meadow, this is a 250-acre meadow straddling the Pacific Crest Trail in the El Dorado National Forest, revived the sponge function of healthy meadows, where the rich organic soils hold on to snowmelt for longer and release it slowly in the spring and summer, providing, in this case, more than a 12.5 acre-foot increase in water downstream during June through September, when people need it the most. With drought and reduced snowpack, we need to build this kind of resilience in as many of the natural reservoirs as we can. Healthy meadows are also great carbon sinks. As any gardener can imagine, the soils in the bottom picture are probably richer than the ones above. In fact, over the past 8,000 years, meadows have collected so much carbon that they're now estimated to hold between 12 and 30% of the carbon in the Sierra region, even though they occupy just 2% of the area. So they're small but mighty. Recent studies, including one that I'm working on with partners, show that in wetter years, healthy and restored meadows can be big carbon sinks, taking up 10 to 20 times the carbon absorbed by the surrounding forest during those years. But we also see that carbon uptake, mediated by the awesome plants in a healthy meadow, varies tremendously from one year to the next, as you can see by comparing the brown degraded meadows bar with the that was measured during the drought, where they're losing a lot of carbon in this year, to the carbon uptake that was measured after the drought in the same meadows. Compare that also to the healthy meadows during the drought. They were carbon sinks, even bigger sinks after the drought. So we don't understand why there's this much variation from year to year in meadow carbon uptake, but we do see that the uptake of the healthy meadows is really big and very important. I also just want to add that rivers are corridors through the landscape, and they link up and downstream lands, forming highways for movement for animals, fish, plants, to get to safer, more livable places as conditions change. So opening up, protecting, restoring these corridors is also key to building resilience into our headwaters and downstream lands. We also need to build resilience in our human institutions. As an example, with partners, American Rivers helped to build the Sierra Meadows Partnership, which now has hundreds of members, over 100 members. Members of the Sierra Meadows Partnership, that is open to everyone, are helping to restore the health of meadows across the state. We're nearly halfway to meeting our 2030 goal of restoring 30,000 acres of degraded meadows by 2030, but we're not slowing down. Collaboration like this can break down silos, expand the number and range of people that are helping out, improve our methods of restoration and management, and increase coordination and then the scale of impact. So we need to help create robust human institutions as well. Okay, thank you for listening, and I look forward to our conversation on Thursday.
Great. Thank you so much, Amy. I really appreciated thinking about meadows as small but mighty, and bringing in fire is something that we really often don't think about. And then the resilience in human institutions is really critical. So I think I appreciate all those. We'll get to some of those topics in the question. So next up is Sarah Yarnell from UC Davis. And Sarah is going to give us—
Hello, my name is Sarah Yarnell, and I'm
Take it away.
a research hydrologist at the Center for Watershed Sciences at the University of California, Davis. In this presentation, I'm going to briefly discuss how we might restore flow functionality and ecological resilience in dammed rivers by managing them with a holistic ecosystem-based perspective. So as we've seen and experienced over the last decade here in California, climate warming has really resulted in an increase in extremes from wet to dry years and a greater propensity to swing from drought to extremely wet. As Peter Glick stated decades ago, in California, we really are learning how to manage our floods to survive our droughts. And this has been a challenge, but not insurmountable for communities here in California. So for example, traditional flood storage predominantly relied on reservoirs. And we're learning that this isn't as flexible as we might need it to be, given the nature of flooding that might come down. And so we've been having a lot of discussions and focusing on alternatives such as putting water out on floodplains, increasing groundwater storage, managed aquifer recharge, and thinking about additional solutions to where we might be able to store water beyond just reservoirs that are going to have to maintain some capacity for flood storage. Similarly, traditional drought remedies such as increasing imports, such as we've seen in California or Southern California, really also aren't as flexible, and they're not really sufficient as our population increases and water supply is becoming more scarce in many places. And so similarly, we've adapted. We've looked to alternatives such as increasing our water conservation, water reuse, diversifying our water portfolio. And so in general, as you know, not necessarily the way we might want to, but Californians have become and are having to become more resilient in how we're approaching these increasing climate extremes. Our native aquatic species, however, are much harder to adapt to these, and we're finding could potentially be harder to adapt to a lot of these climate extremes. So there's an example here of salmon and who rely on cold water down in the rivers, or our forests, as we're learning, are becoming more susceptible to warming and increased evapotranspiration. So as we move forward to think about our freshwater ecosystems and maintaining the ecosystem services that they provide, we want to think about how can we increase the ecological resilience of our ecosystems for their benefit as well as ours. And so when I think about ecological resilience, what I mean is the ability to really adapt to changing conditions. We're not talking about resistance or ecosystems being resistant to climate change, but rather resilient, where if they are perturbed or have an effect from climate change, that they'll be able to recover more quickly and hopefully recover back to the types of functioning that they had before. And we know that more diverse systems are better able to respond and adapt to changes or perturbations in the system or disturbance in the system. And so this figure down here on the lower right shows an illustration of the idea of a shifting habitat mosaic of natural river systems. So the river system is moving, it's dynamic, it's changing on a regular basis, but at any given point in time, there's a variety of niches and habitat that is available for a whole variety of species to occupy. So it's dynamic, it's adapting, it's changing, and yet it's providing the functioning that it needs. And this really leads to high biodiversity and a greater possibility for species to persist over time. So we know from a lot of the research that's happened around this that high biodiversity really results when you have these functioning ecological processes. When we have the structure and the function there, it's able to inherently work the way that it has. And so if we think about how do we maintain or support this ecological resilience in our California rivers where they're heavily managed and have been heavily modified, one of the things that we can do is think about how to maximize our adaptive capacity within those rivers. So what is it about their structure and function that we can preserve or restore or maintain in order to really increase that adaptive capacity? So two things we can focus on are to the hydrologic variability, restoring and preserving that natural variability that happens within rivers and our annual flow regimes that we have here in California, as well as the geomorphic complexity or the different habitat types that are occurring within the rivers. So we can enact or enable or implement certain types of environmental flow regimes that focus on preserving that natural hydrologic variability. And we can also think about restoring channel habitat and floodplain connections that support that greater geomorphic complexity. So one thing we can think about in environmental flows is to move away from this idea of focusing on flow volume and as well as focusing on a single species. It doesn't really help us to think about what does this one species need at this one point in time and how much water does the river need in terms of a flow volume, but rather let's focus on the hydrograph flow components that we want to maintain within a system that provide these natural functions. So two examples are shown in the figure here on the right, where depending on the type of hydrograph, what is the magnitude of the flow, when is the flow coming down, we can see that different types of abiotic or biotic functions might be happening. Higher flows scour more water in more places. You know, we get floodplain succession happening and riparian succession happening when the water gets out on the floodplain and can move around. Similarly, flows that come down in the springtime at the appropriate time when, say, cottonwood seeds are being released, those cottonwood seeds are going to be able to spread out throughout the river system and perpetuate and hopefully turn into more cottonwoods, right? So we want to support those natural disturbances that really drive the ecosystem functions and think about putting down the flows that are going to best be able to do that. And we have to take into consideration as well the geomorphic setting and the channel floodplain dynamics. Flow does not operate in isolation from the landscape over which it evolves. It's this connection between flow and habitat and the landscape underneath that really together work to create this functionality that we're hoping to maintain within our systems. So we can, here's an example of what a functional flow approach might look like in a river. There's a variety of ways that we can think about doing this. But in this example, we've got a mixed rain snowmelt regime. We've got peak flows coming down in the wintertime that might be driven by high rain events, followed by a spring recession or a snowmelt pulse from the higher elevations. And so we might consider focusing on 4 key functional flow components that provide distinct functions, such as the wet season initiation flow, a peak flow, a spring recession flow, and a dry season base flow. And so the wet season initiation flow or the fall pulse flow is really important for migration cues for salmon and other native fish to migrate upstream. It's also very important biogeochemically to instigate carbon cycling, reconnect with the riparian zone and really flush through a lot of the nutrients and detritus that have built up over the summer. The peak flows are important geomorphically. This is where we get a lot of our scour, our reworking of the habitat, rejuvenation of the habitat. And we might not need to release every single peak flow that might naturally come down, but it's important to release some. And we might choose to store some of those other peak flow events for storage for use for humans. The spring recession flow is hugely important ecologically because of the timing. These are cues for species to migrate out migration cues, spring salmon, split tail spawning, for example, out on the floodplain, frog spawning, cottonwood seed dispersal, sediment sorting. The predictability of the spring recession flow is so key that so many native species have evolved to take advantage of this time of year. The spring recession flow also allows cold water to stay into the system for longer into the summer. It's really prolonging that cold water and shortening the dry season, low, stressful, warm flow time of year that can be really stressful. So by maintaining that, we add a lot of benefit into the system by releasing water during that time. And then over multiple years, we can think about changing up and thinking about what degree those functional flow components might need to be, how big, how long, when is their timing, and that might shift from year to year depending on whether we're in a wet year or a dry year. The idea is that you're providing these key functional flow components in every year, but the nature of that component, how much of a volume, how much of a magnitude should you put down, how long of a duration does it need to be, when should it occur, can have some flexibility, and that flexibility is actually important in supporting and increasing the diversity over time, right? It supports diversity in habitat, and over multiple years, you're going to be providing habitat conditions for the native species that have adapted to these types of variability in our flow regime. We can think about the spatial variability and flow as well. So if we think about how we might coordinate flows between different reservoirs and tributaries that come downstream, we can think about the timing of when we release flows out of different tributaries, how much water might come down, the nature of that water, so that collectively together, by the time you get to the downstream end, you really have this cumulative effect, impact that can really serve a lot of greater functions. So the idea is that operating these types of tributaries independently isn't as great as it could be if we could operate them more collectively and more cohesively over larger spatial scales. So finally, functional flows really do need to function. And so I want to repeat this point that it's really important that we consider the geomorphic landscape over which the flows happen. So we need the flows to come down at the right time in the right volume, and they need to interact with the landscape in a way that really maximizes that functionality. So this might take into account the fact that we might have to do physical habitat restoration. We might want to do some floodplain lowering or levee breaches in order to reconnect to the floodplain. And it's really not about flows or habitat. It's about both flow and habitat together, working together to create that holistic picture of functionality in the system that the species need. So in order to restore flow functionality, within rivers, we really need to ultimately be thinking about supporting biodiversity. And this is going to require holistic interdisciplinary thinking that really addresses, these are complex issues, and it's a complex problem to solve. But we want these rivers to be dynamic, our watersheds to be functioning, so that intrinsically they are able to do the best that they can to adapt to changing climate conditions. And we need to think about this on a large scale throughout California and throughout how our watersheds work together. And if we can increase this flow functionality and ecological resilience, we'll be in a better position to continue to support those associated freshwater ecosystem services that we and our communities rely on. All right, thank you very much.
Great, thank you, Sarah. That was an incredible overview of all of those challenging and complex issues around flow functionality, and I really appreciate how you linked together the flow, variability, geomorphic complexity, and biodiversity issues. So our next speaker will be Jacob Katz. Jacob is at CalTrout, and Jacob is going to give us an overview of floodplain issues.
Good morning, Delta. My name is Jacob Katz. I'm lead scientist at California Trout. Thanks for joining me on a 10-minute whirlwind tour of the floodplain beyond the thin blue line. The way Westerners have conceptualized rivers as a blue ribbon between two steep, often levied banks might be able to be summarized as saying that fish belong in the river and the river belongs in its banks. And that sentiment really has been a major driver in taking California's Great Valley, once a vast network of river wetland corridors, and converting that into the agricultural valley we know today. And that happened by simply piling up dirt near all of our our stream channels, divorcing the water from the landscape, and making sure that that water, when it did get out into the landscape, got off as quick as possible. Rapid drainage. People are basically anti-beavers. Get that water off quick. Drain the swamp, right? That's certainly the story of the Delta, where a majority of the energy, the food energy available to the historical Delta came from the marsh surface. And conversion of over 98% of that tidal and freshwater marsh led to an over 90% reduction in the net primary production in the Delta itself. The take-home, of course, is that land use fundamentally alters the flow of energy through the landscape and through food webs and ecosystems. And fish are a fantastic lens, a bioenergetic window into how energy flows through the landscape. This picture, famous of course from the Cosumnes and Carson Jeffries' work there in 2008, was the first real indication, the first window into how the river should work and how a fish uses it. This was the first picture of Sacramento salmon as it should be, right? We understood at this point that re-exposing these fish to the kind of biophysical conditions that they're adapted to, in this case, the fact that they would get out of the stream channel and into those fertile off-channel habitats on the Cosumnes River floodplain, was really exactly what should be happening. But there wasn't a lot of floodplain there on the Cosumnes, and we went up into the Sac Valley. And the Sac Valley, of course, has had a very similar land use development and evolution as the Delta, right? As this graphic shows, that's the Sutter Buttes right in the middle of the valley there, and all those different shades or different kinds of a mosaic of different wetland habitats. This was around 1900. Today, there's very small remnants, maybe 5% remnant floodplain, and then in those formerly activated floodplains, that's now the primary location where rice is grown. So we went into the Sac Valley thinking about how we might reconcile the landscape we've inherited with this burgeoning understanding of how the system worked, of how rivers worked, and how fish used them. And we flooded rice fields in winter, in the off season, the off growing season, to create surrogate wetlands, surrogate marshes. Certainly not what a marsh looks like on the outside, but could we mimic the ecological processes within these seasonal wetlands, and would fish respond? And the answer was that yes, they did, just dramatically. That fish trapped within river channels grew very little, yet those exposed to these kinds of off-channel biophysical conditions grew very rapidly. And we gradually began to understand why, that the food is on the floodplain, that there was up to 15,000% more food available, and high quality food on one side of the levee than the other. And that was fundamentally tied to the residence time of water, that the water in the river turned over every couple seconds, that the water in canals turned over every half minute or so. In these managed agricultural floodplains, water was turning over every couple days. But historically, in the great ephemeral flood basins of the Sac Valley, in the Natomas and Yolo and Sutter basins, you would have had shallow inundated floodplains that stayed wet for months, even sometimes in big water years all year round. So the duration is fundamentally different. The duration and residence time of floodwaters is really important, right? So the point here is that this it does take time. We found that it takes around 3 weeks to go from inundation to a food web that's absolutely teeming with invertebrates. So about in that 3-week window, but it does take time, right, for sunlight to be captured by phytoplankton, floating in the water column of a inundated floodplain, or for microbial action to break down the vegetation that was there, capturing summer sunlight previously. But either way, you have a microbial and bacterial food web feeding on that, the photosynthetic products, right? And then that feeds an invertebrate food web that, small fish feed upon and rapidly become big fish, but not overnight. It does take time, right? So what we know is floodplains are still here. They still exist. This is an 1888 map of the shading there represents the Tule basins of the Sacramento Valley. And what you'll see is this is overlaid now, just fading into a contemporary satellite photo. And what you can still see there is that shading, that 5 o'clock shadow of those deep, fertile marsh soils is still visible from space. We have the capacity and the opportunity, maybe even the obligation, to integrate our 21st century understanding of how these systems worked, about how rivers worked and fish used them, into the way we manage our Great Valley, right? On the wet side, on the side of the levee where fish can actually access these off-channel habitats, we see that they become very, very big very quickly, right? So this is time-lapse photos of fish rearing in Yolo Bypass, and these fish are doubling their mass every week, right? This is the making of a floodplain fatty, and everywhere we can, we need to allow these fish to swim onto floodplain habitats, to access this kind of energy source, and then to swim off of their own volition. But we also must understand that the vast majority of the formally activated floodplains of the Great Valley are now behind flood protection levees, no longer available for fish to actually access easily. But that doesn't mean that those fields, those managed marshes can't contribute to the floodplain food web and to benefit fish. And we have been working with growers and water districts to inundate large areas. In this case, this picture represents about 7,500 acres of experimentally inundated ground that we then drained right back to the Sacramento River. That's the Sacramento River you see there in the foreground. What we saw was that fish upstream of the outfall, where this floodplain-derived food web subsidy was coming into the river, grew very little. But fish at the outfall grew 8.3 times as fast, and then fish even 6 miles downstream were still growing 4.5 times as fast as those upstream fish. Right? So we have the capacity to put the batteries back in the system, to understand that energy in is going to equal biomass out, right? That these are the mathematics of recovery. This is how we regain abundance, right? This is how we no longer should be surprised that when we cut off 95% of our floodplains, we end up with 5% of the fish biomass, right? That we now have the opportunity to put the science into action, really to take this process-based understanding of how rivers worked and how fish use them and integrate that into our water management. Understanding that very similar process-based reconciliation is happening across all of our resource disciplines, right? From rangelands to timber and fire and even engineering, right? So if you take only one thing home, take this, right? That we can mimic the landscape scale riverine processes. We can spread it, slow it, sink it, grow it. And in so doing, we can harness puddle power. Thank you.
Great. Thank you so much, Jacob. I truly appreciated how you highlighted that importance of residence time, that humans really were anti-beavers. I love that. And that we do have the capacity to put the batteries back in the system and make things get to work. So we will continue our journey down the watershed, and we'll move into the estuary and hear from Scott Dusterhoff about sediment issues in the estuary.
Good morning. My name is Scott Dusterhoff, and I'm with the San Francisco Estuary Institute. And I'm going to move us downstream now into the lower estuary and discuss the future of sediment in San Francisco Bay. So I will be discussing a recently released report called Sediment for Survival that looked at the future of bayland sediment demand under a rising sea level and how that compares to the future of sediment supply, and then used those results to develop a suite of management recommendations aimed at supporting bayland resilience over a range of timescales. So in my time here, I will be focusing on the key takeaways from this report and discussing ways that we can get more sediment out onto our baylands so that they can be more resilient. But I want to start out here with some quick acknowledgments, thanking this effort's Technical Advisory Committee, Management Advisory Committee, as well as other folks that provided essential review and oversight and data sets. So tidal marshes throughout the estuary provide a range of important services, right? Shoreline protection, water filtration, habitat, the list goes on. And it's no secret that over the past 200 years, we have lost thousands of acres of tidal marsh in the estuary. But we as a region are committed to bringing much of that back. So in the early 1800s, about 200,000 acres of marsh in the lower estuary in San Francisco Bay. Today, something closer to 50,000 acres. But through the Bayland Goals effort in the late 90s, we as a region committed to getting back to 100,000 acres of marsh within San Francisco Bay. And getting back to that much marsh is going to require a lot of sediment, due in large part to the fact that many of the areas that we want to turn back into marsh are currently deeply subsided holes in the ground. And it will require a lot of sediment to get those holes filled up to current marsh elevation so that those areas can be marshes once again. And as we look to the future, we know that climate change is going to be presenting challenges because as climate continues to change and sea level continues to rise, we will need more and more sediment depositing onto our marshes to help them build up in elevation and keep pace with that rising sea level. So we as a region want to understand the long-term forecast for sediment delivery to our bay marshes and our bay mudflats. So the questions we are asking as a region and the questions that we addressed within this study are, first, how much sediment do we think our marshes and our mudflats will need in the future under a rising sea level? Second, how much natural sediment supply do we think will be available to our marshes and our mudflats? And then, spoiler, we don't think there will be enough natural supply under our current management approaches. So then, how can we get more? Where are the additional sources of sediment that we can call upon to get onto our marshes and our mudflats and help them build up in elevation and be resilient? So our effort focused on addressing these three questions. So what did we find? Well, we found that by the end of the century, under 6.9 feet of sea level rise, we'll need approximately 450 million cubic yards of sediment to support all the marshes and mudflats we have out in San Francisco Bay today, and support the 24,000 acres of tidal marsh restoration that we say we want to do in the Bayland Goals effort. So how much sediment is this really? Well, it's enough to fill a cylinder this size. Okay, here we have downtown San Francisco, the Bay Bridge. It is almost twice the amount of dirt that was taken out of the ground to build the Panama Canal. And it is enough sediment to fill about 45 million dump trucks, which, if put end to end, would circle the equator 10 times. So it's an incredible amount of sediment. And I think it's important to point out that 100 million of this is needed just to fill those deeply subsided holes we want to restore back into tidal marsh and get them up to current marsh elevation. Okay, so where is all of this sediment going to come from? Well, we think we can get about 30% of it from what I call here our current landscape and our current management approaches. Okay, so what does that mean? That means natural depositional processes. So under our current landscape configuration, that's the tide coming onto our marshes and our mudflats, and much of that sediment in suspension depositing before the tide recedes. So that can get us part of the way there. And so can using dredge sediment as we've been using it to date, using dredge sediment to fill deeply subsided areas before turning them back into marsh. So here's a map of San Francisco Bay, the red lines indicating where the Army Corps of Engineers currently dredge for navigational purposes. And currently, on an average annual basis, about 40% of that sediment goes to marsh restoration projects. The remaining 60% goes either out the Golden Gate or is deposited elsewhere in the bay. And what we see here in green are the areas where dredge sediment has been placed for marsh restoration projects to date, and then the yellow and orange indicating where there are plans to put dredge sediment for restoration projects in the future. So dredge sediment, a big part of the marsh restoration efforts in San Francisco Bay. So that gets us part of the way there. What about the remaining 70%? Well, the good news here is that we think that sediment exists in the region. We just need to be better about getting it where it's needed. So we need to bring online new management approaches to access more in-bay and watershed sediment and get it out onto our marshes and our mudflats. The first is bringing more dredge sediment into play for our marshes and our mudflats. So currently, 3 million cubic yards of sediment dredged from the bay every year. And as I said already, about 40% of that going to restoration. Well, because we have this great need, more of that sediment should be going to restoration projects and supporting our marshes and our mudflats. The next piece here is upland excavated sediment. So this is sediment from construction projects. So currently, about 2 million cubic yards per year of construction sediment goes to landfill within the San Francisco Bay region. So again, because of this deficit, we should be finding ways to get that sediment trucked down to our baylands where it can help with long-term resilience. And then the third piece here being upland reservoir sediment. So that's the sediment trapped behind dams within the region. So we estimate that by the end of the century, there could be somewhere in the neighborhood of 100 million cubic yards of sediment trapped behind all the dams within the San Francisco Bay area. Again, because of this deficit, that sediment could be removed, taken downstream, and used to help support long-term bayland resilience. And that would be a win-win because it would help with reservoir capacity as well as help with bayland resilience. So the Sediment for Survival report really points to 3 types of management actions needed to support long-term bayland health and resilience. So essentially a 3-legged stool approach to management that plays out over a range of timescales. So in the near term, the report points to the focus being on dredge sediment. Okay, so bringing more dredge sediment into play for restoration projects and bringing dredge sediment and upland excavated sediment into play for augmenting natural sediment supply to our marshes and our mudflats. And then there's 2 other components here that we call longer term. So not longer term in the sense that we can wait to act on them, but longer term in the sense that it will take a while for them to be realized. And the first one here is protecting marsh migration space. So we know marshes will migrate inland as sea level rises if they're given the opportunity. So we really should be focusing on protecting those low gradient areas just inland of marshes today, so those can be the areas where marshes migrate to in the future. And the last piece here is a new approach to watershed management. So that means managing our watersheds to be ready for a changing climate and associated changes to both flows and sediment supply. That's going to come with more intense storms, shifting vegetation patterns, and increased wildfire frequency. But doing this in a way that benefits both the watersheds and our downstream baylands. So getting there will require an integrated approach to watersheds and baylands management. So getting those that manage watersheds to coordinate with those that manage baylands to bring online new management approaches that improve the natural transport of sediment through flushing flows, through expanding floodplains and allowing natural channel adjustment, improving sediment delivery pathways to our channels, and then also affecting hydrology through LID. And down at the shoreline, bringing online new approaches to putting treated wastewater into the tops of our marshes to help build up organic material and improving the connections of our watersheds and our baylands so sediment-laden flows can actually easily get out onto our marshes. And then it also means bringing online actions to increase the supply and reuse of sediment. So that's reservoir excavating sediment from reservoirs and from construction sites, moving that downstream to our baylands, and then also bringing more dredge sediment from navigational channel dredging on to our marshes and bringing that into play for long-term bayland support. So that's a high-level overview of the Sediment for Survival report and its key findings. In closing, I want to thank the funders, the EPA and the RMP, as well as the project partners, and I look forward to the discussion.
Great. Thank you very much, Scott, and thanks for providing that link in the chat. I'm sure I definitely encourage people, if you're at all interested in sediment issues, it's a very valuable report to look through. And I appreciate how you guys thought through those, how you really thought about issues across the entire watershed, how those management issues link to the bay, and how you really did think about some of the issues across a mix of timescales as well. So we will now move to our last presentation for the morning. Lisa Marie Wyndham Myers from the U.S. Geological Survey is going to give you an overview of carbon issues in the estuary.
Hi, I'm Lisa Wyndham Myers, and thank you for watching this talk on blue carbon. I'm going to talk about the salty end of our watershed, where all these upland pressures still have effect, but there's a new driver, the ocean, which is actually doing a lot of climate work for the globe, storing heat and carbon dioxide that would otherwise be driving even more extreme weather. The oceans are also rising at about 3.5 millimeters a year globally, but it's somewhat of a Goldilocks setting in which coastal wetlands can continue as a negative carbon feedback, a stabilizing feedback. Coastal wetlands grow with sea level rise, as you know, with very rapid and continuous accumulation of soil vertically, and then migrating out into the bay when sediment is abundant, and inland when sea level rise allows it because there's no barriers. This deep, rich blue carbon deposits in the soil are ultimately based on the stabilizing power of the ocean, which I'm going to call a press disturbance, one that is in fact stabilizing for these adaptive landforms, as opposed to the destabilizing pulse disturbances of fires and floods. So the real question in the end about where we're going to be in 20, 50, 100 years is whether we're going to fight the ocean or leverage some of this stabilizing power. I want to reconsider that ocean as a stabilizer because they've been responding for millennia. And we know this because of global evidence, regional, local evidence, and modelable evidence. I'm just going to point here to the middle where you can see that ocean, through relative sea level rise, is basically the biggest driver of carbon accretion rates in wetlands for the the continental United States. And here in red is California. So we're way down here in the 100 grams of carbon per meter squared per year range, whereas up here, is more Louisiana, where the land is sinking, and yet the carbon accretion is continuing. We know these, we can model it because we measure things. We have soil profiles all over the world. Different ages and characteristics have been monitored. Here in San Francisco Bay, we have about 139 sites that anybody can grab off the Coastal Carbon Atlas. And when we just think about the 3,000 sites across the country, with many, many depths, and the 6,000 sites across the globe, we can see that they start to follow this power function, which is basically saying that the heavier you are in the soil, the more mineral, so less organic carbon in the soil. And these more peaty soils are basically lightweight, as well as being more carbon rich. So this line is about 0.03 grams of carbon per cubic centimeter. If you're above the line, more like 0.04. If you're below the line, like here, China Camp in gray, you're more like 0.02. And so, we don't see any pattern here with salinity or plant type or depth. It's pretty fascinating. And in fact, Judy Drexler's sites out here in freshwater sites is about 0.039 grams of carbon per cubic meter. So on the higher end here, and that goes back basically 8 meters deep, so 6,000 years. That's what it's looked like. The other thing, we have a lot of data here in San Francisco Bay is on carbon fluxes. So we have eddy covariance data from 40 site years. This includes the salty edge here down in Hayward, but Patio Kawa runs. Up here in North Bay and Rush Ranch, we have USGS sites ongoing, the point person being Ellen Stewart Henshin. And then out here in the Delta, we have many different groups working. Dennis Baldacci would be the main group. And if we look at all of these sites, we're seeing basically high CO2 uptake all across the region. And what's really different is you have high methane emissions here in the Delta versus low methane here in the more salty and tidally influenced sites. The other thing interesting is when you start measuring lateral fluxes, you'll start to see that they're important. They're upwards of 50% of the net primary produced every year. And therefore, that term is an important one to closing a net ecosystem carbon budget. We also have enough data in the bay to do a lot of elevation resilience modeling. I think you have seen some of these talks already. If we think about tying that to the carbon story, we can basically forecast what carbon sequestration is going to look in the future. We can hindcast to make long-term soil records and see how they're related to past sea level rise and sediment supply and so on. And ultimately, we can just test a range of scenarios because we have a model that can reconstruct the cores that we've observed. The resilience is a huge part of doing carbon accounting, but so is these other tidal connectivity benefits like carbon exports to food webs and supporting the open ocean carbon sink. We have a strong effect of being tidally connected on reducing methane emissions. We believe it's because of marine sulfate. The supplies are high enough that you can push down, you can have enough salt to basically make sulfate the dominant driver, not methanogenesis. And so with more eddy covariance data here in the triangles, we're seeing that that curtain is pushed down. You don't need necessarily half strength salinity, but getting to about 5 parts per thousand seems good enough. And of course, as you know, being connected to the ocean allows you to have a sediment supply that's high enough to continue accretion with sea level rise. The real kicker here is elevation and elevation capital. Elevation tells you what can be tidally reconnected. So here we have this deep bowl in the delta, of course, through all, the last 200 years of subsidence. But are these light green areas you can see are all sites that can be tidally connected again and have the potential to restore those functions. When you think about Z star, which is basically the relative elevation, where you are in the tidal frame, that also tells you the chance of success, how much elevation capital you have under accelerated sea level rise. Tipping points is the ultimate question. We all know that at some point sea level rise is going to drown the marshes. And the question is how much confidence can we have in that rate? So for example, two important drivers here are biomass. And what you can see is that if you're above the biomass optimum peak, if the plant is the Stickless spicata up here, raising sea level might actually pump up the productivity of that plant. If your plant is poised below the optimum, then raising sea level, for example, is going to lower the biomass production and then have less accretion. The other important thing here is mineral contribution, as you've heard. So as the rate of sea level increases, of course, accretion increases. We know this from modeling. But if you have more and more mineral components, you can have more and more accretion, and you can push out that resilience window to be able to withstand higher rates of sea level rise. A clearer understanding of what promotes ecological resilience under climate change is needed for effective long-term management of tidal wetlands. Resilience metrics are needed that can be applied across all tidal marshes and then determine a threshold for marshes in decline. So here's two new approaches from Jim Morris and Judy Drexler. One shows the predicted time to tipping points where vertical accretion starts to decline with increasing sea level rise rate, which is basically a slippery slope for marshes. And the other uses a metric from finance to determine an optimal mix of both risk and reward, and the risk being here on the x-axis, vertical accretion, and the reward being final elevation. And you can see that if we can try to target this super optimal plant growth range when we do restoration or preservation, this is where we're going to have the highest reward to risk. A clearer understanding of climate mitigation benefits over time are also needed, and better communication of this. Simplifying benefits to radiative balance and crossover time gives us a way to model over time how an action helps carbon sequestration, either by increasing carbon dioxide uptake or by reducing methane emissions, which are 45-fold more effective as greenhouse gases. So from doing this, you can see that, for example, freshwater sites, it's going to take a long time for it to become at least net neutral, if not a sink. Here is data from a Virginia freshwater marsh. It took about 800 years here. And then here in the Delta, from some work by Arias Ortiz, we can see it takes, for the non-tidal sites, about 200 years or 400 years to get to this neutral and then crossing over into a net carbon sink point. Another important point here is that the tidal wetland, Eden, is constantly a sink. It never is a net source. And the other important point here is that Our 5,000-year-old millennial peats here in the Delta, regardless of any methane they're producing, have a net cooling effect by virtue of their soil being left alone and stabilized. So all of these carbon services in coastal wetlands are maintained by connectivity to the ocean. When we think about our alternative futures, where there is an ocean influence, we should maintain it and help out as needed to allow migration or stimulate sediment supply. Where there is not ocean influence, we should return it where elevation or operations allow it. And it's how we respond to the ocean, really, that's going to tell us where our landscape functions are in 20, 50, 100 years. From a global perspective, the ocean has been a stable sink for atmospheric carbon and for heat for as long as we've been able to measure. So for all the CO2 that we put up into the atmosphere, the ocean and land sink take up half of it. And the ocean just is pressing along, doing its business. The land sink is the one that's very volatile and as it is really responsive to pulse disturbances. Coastal wetlands, because they are influenced by both the land and ocean, are thus susceptible to both these press and pulse disturbance. But their sinks can be stabilized and then provide a long-term removal of CO2 from the atmosphere. So in closing, blue carbon ecosystems are adaptive and mitigative to climate forcings by nature. Their feedback to the upper watersheds is ultimately one of stabilization as they keep bearing carbon and thus mitigate emissions that encourage extreme weather. That stabilization is key, and we have inherited a history of atmospheric cooling through ocean-driven burial. We should protect this inheritance by avoiding soil destabilization wherever possible. We haven't talked about water quality, but that is another important effect of physical landscapes, including the big four: temperature, salinity, nutrients, and suspended sediments. I suggest that as we develop a vision for Delta 2.0, we don't think of the ocean as an enemy, but rather as a significant stabilizing component that we can leverage to counteract the many upstream and local disturbances we have to live with in this volatile and unpredictable world. Thank you.
Great. Thank you very much, Lisa. Clearly, carbon is right in the middle of all of our discussions in addition to the other topics that we've hit. So if all the panelists could turn on your camera now so that we could have a discussion, that would be great. And I have a few questions to get things started with. And they're also, I'll refer to questions that are in the Q&A or put up on Mural. And actually, one of the questions on Mural really aligns directly with the first question I wanted to ask. And so that is, what do you think would be the most effective next steps or action items to move these issues forward? Everyone highlighted challenging issues, some suggestions, but what do you think would be immediate priority issues to address that, and especially thinking for your system or your focus, as well as more broadly across the watershed? So start out with a real easy question. What should we do first? And I would encourage you guys can all just unmute yourself now, and then just jump in as you'd like.
I'll pop in, risk taker.
Thank you.
I guess one of my first thoughts is to try and leverage all of this knowledge that we have and integrate it in the best way possible by supporting collaboration among people that are going in the same direction. And one thing that we didn't talk too much about, I guess I mentioned it, was the importance of really bringing in all of the people that are being impacted by this, including, the vulnerable communities too. So anyway, I'm just thinking back on the Sierra Meadows partnership and how that has really blasted off the efforts to restore meadows. And I think we should just do more of that at scale.
Great. Others? Chime in, Sarah?
Sure. So kind of building on what Amy said, in the environmental flow realm, there's been actually a similar sort of effort with a lot of collaborative work that's gone together. The new California Environmental Flows Framework that's been put together is out. I put a link to the website into the chat earlier. It's a similar idea, exactly like what Amy's saying. That was for the Sierra Meadows Partnership, is you've got agencies, academics, NGOs, coming together to kind of create a more holistic framework for how to approach these issues throughout the state. I'll also just make a comment that under the Water Quality Monitoring Council, which is the overarching group that, for Cal EPA and the Natural Resources Division, there's an environmental flows technical working group that meets quarterly. So it's, again, this push to try to bring together a lot of these disparate siloed agencies and folks working so that there's at least a place to talk and communicate and try to advance projects, at least in awareness of the other things that are going on. So I think there's a lot of potential there as well.
Great. Jacob?
I'll jump in. Sure. I don't mean to be glib, but the first thing we got to do is stop talking and start actually doing something. If you're a fish in this world, through my entire lifetime, things have got worse, not better, despite that we've been in pretty common agreement throughout, again, the whole time I've been alive, not just working, that we need to give rivers a little bit more room, right? That we need to start to mimic some of those, we can call them habitat conditions, biophysical conditions, whatever. You got to let fish recognize the rivers that they evolved in. And despite one symposium after another, despite one report after another, the world isn't changing very much if you're a fish. So I think that it's really incumbent on us here on these calls, on everything, despite being comfortable and getting a good paycheck talking about this stuff, that we really have to put the science into action. We have to change the physical world. We have to let fish actually, get out there, not just fish. This applies to everything. When I say fish, it means the native animals and plants. We have to change the physical world. We have to work. We have to give those critters a chance.
Great. Thank you, Jacob. So let's hear from Scott and Lisa Marie, and then we'll come back to some of these issues.
Yeah. Okay. So, I definitely second Jacob. I mean, we can talk this to death, but we need to move. But at the same time, I do think, like this session we have right here, more coordination amongst folks that are managing Sierra headwaters and folks that are managing Bay wetlands is important. So we know when we turn the knobs further upstream, what the impact is further downstream. One big example of that is sediment supply to the bay from the Delta. So in what I talked about is, we assume that the sediment supply from the Delta does not include all the restoration that is being planned in the Delta, because we don't know what the impact of that is going to be yet on sediment supply to the bay. So there's some coordination that needs to happen there so we can understand how things will evolve in the bay. I guess that's one thing. And then the other thing to mention is what we need to do within the bay is figure out how to keep more sediment in our system and also get it where it's needed, and then have nature as much as we can be that engine to get it where it's needed, because that's always going to be cheapest. So we can't study this to death. I definitely agree with that sentiment. We need to move, but we need to do it in a way that's smart and forward looking and is having nature, really do the work for us as much as we can.
Great.
Amen.
Thank you, Scott. Lisa.
Yeah, I second both Scott and Jacob about just action moving forward, and the idea that we need to start talking between the two zones of the Bay Estuary. I like the idea from the first day yesterday about the way things happen is to have a better story. I think it was the artist who said that. And it's just, if we're not talking about the same integrated story, then we tend to have different approaches, and it's not working right now. And I'd like to see tides basically be not such a negative. Tidal influences is clearly part of moving sediment. It's part of the variability in residence time in those backwater areas everyone talks about. So, and it's important to refreshing marine-based sulfate and sediments and so on. So yeah, I'd like to see a better story.
Great. Okay, well, so we've heard a mix of things, and I would say when I was at the council and working as lead scientist, I'm sure Laurel can highlight some of these issues in the final session. There definitely is a tension that was highlighted right here of we do need to put a lot of effort into collaboration, and that I think we hear that more than anything. But I agree with the sentiment of we also need to act and not just talk. But so to push you guys a little more, what if you were in charge and you could highlight some immediate actions, what would be some projects or what would be some things that you'd like to see done that you think could begin to get some movement and some momentum towards shared activities within the watershed? any thoughts on, some either pilot projects or issues that you'd really like to see addressed?
Well, I'll tackle that right just initially, which is I think that story, that common vision, that articulation of how, of what a working landscape is from ridgetop to river mouth is absolutely critical for that integration. And that when we do that, we see that there's so many things that are absolutely necessary, yet are all insufficient in themselves. But that doesn't need to lead to paralysis, which it so often does, right? Where we're looking to, well, is this more important to that, right? We as scientists, we as conservation practitioners, I think can come together with that common story, with that common integration and landscape scale connectivity and process base that says, here are a bunch of things that can be done. They can be done in phased ways, but that it doesn't, so often uncertainty of any kind, and science is based on uncertainty, is used in a way to really preserve the status quo, to keep, when action is seen as the safe, inaction is seen as the safest way by many in leadership roles. And I think it's incumbent on us to put forward that larger vision that then moves down into programs and programs into projects. So there is a real specific roadmap for moving forward. And we can talk about the specific projects. That's what I think what you were just asking, John. Yeah. But that if we don't connect those three things, right? The science moves in and informs the projects roll up to programs, and the programs integrate each one of these different biomes in the landscape that we've been talking about. We're not going to get there. It falls, we get that tension then between the scientific and conservation gears and the political gears. So that's my thought.
I love that, Jacob, and I think I'd like to, we haven't talked about the San Joaquin, although it is part of our watershed. It's really different, as we all know. It's a radically different place than the Sacramento. And we've been working a lot on the San Joaquin, and yes, totally, we've got to chew gum and walk at the same time. So we have to collaborate, work together, coordinate, and then we have to definitely do stuff on the ground. And hey, they work together, they inform each other. So it's good. And in the San Joaquin, as within the Sacramento, I think we need to restore people's connection with the rivers. And there's a lot of people, there's us, we all love our rivers, we're in them all the time. Yes, yes, wetlands, get my hands dirty. That's not true of everybody. We need everybody to be connected with the rivers as much as possible, loving them, providing the political support to live with, have our economy built on, our lives healthier with good rivers. So I think that can be part of our walking and chewing gum at the same time. We can restore rivers, restore the connections, and restore the people's connections to the rivers, and that will move us forward. Just want to make that point.
Thank you, Amy.
Yeah, I guess I just want to quickly, if I could just echo that quickly further downstream into San Francisco Bay. So the idea of getting people engaged and excited about the Baylands, and there plenty of people are. I mean, just a few years ago, the region passed Measure AA to put funds, this is voter approved money, to put funds every year towards Bayland restoration. So it's an engaged, population down here, but I think we can do better. And if we had more people understanding the value of Baylands just from a recreational perspective, that would be helpful. But then also just the value of tidal wetlands with respect to what the shoreline protection that it gives is important. Because I think if people understood what was at stake if the wetlands went away, I think the alarm bells would be ringing a lot louder. So I think it would help our restoration cause down in San Francisco Bay and within the Delta to really, if we can figure out a way to engage the population better so that they kind of get what we all get, I think we would see more money flowing, and I think we would see more political will.
So that was definitely a theme yesterday in terms of engagement issues, and also very specifically inclusivity issues, and really, moving beyond the typical people that are informed and aware of the Bay. So any specific thoughts that anyone has on how do we do that effectively? How can scientists engage on that to really promote awareness and to bring in a broader audience?
Well, there's two things that come to mind for me. The first is telling those stories like we've talked about, and it's really important that we tell them in ways that really make sense, that are compelling to, you know, our largely urban populace. I think that's entirely possible. From my perspective, the best investment in California's most precious resource, right, in water security for our population, is a functioning ecological system. You know, a working river ecosystem is the best investment in the Bay Area and Southern California's water security. So being able to tell that in a way that really makes sense to urban folks, I think, is important. And then the next is to actually, you know, not just to do it, but to be successful. We have to actually build on success. We have to go out and demonstrate. We can talk to our blue in the face, but if we go out and do it, if we demonstrate what landscape scale projects look like and that they actually have the potential to move the needle, to have a population level response, to make things better, then we actually will see that California is willing to invest and to do this at the scale that's needed. And so again, have really good stories that are told simply, and then go out there and build things at the scale that's needed so you can actually demonstrate success, and success builds more success.
Great. Sarah?
Yeah, I was just going to add a little bit and build on. I totally agree with what everybody else has said. So to answer your immediate question, I think I would add that there has been a definite need for outreach. And I've been very encouraged by a lot of the activities that folks have done to get kids, high schoolers, out to learn about where their water comes from, to learn about these issues of water quality, and to tell these stories in a way that relates to them, right? That's going to help build that awareness and educational awareness and support. And it's also going to help to really reach a whole diverse audience of, we know, through the public schools that are out there. So those programs have been really great. They're not well funded, and there's not necessarily a lot of people that have the time. So the other piece that I would add in regards, kind of going back to one of the comments that Jacob made about the story. So I would say we know the collective story that we're telling. We just did it in our panel presentations. We know the story, and we have a new solidified approach in terms of process-based restoration, connectivity. Now what I think the next steps are is really getting that word out, explaining it, helping folks understand it. The collaborative working groups that have come together across different agencies are talking about this and collectively chewing gum. I like that analogy, walking and chewing gum at the same time. You have to be putting these things on the ground. The other piece that I have run into myself that I find is lacking is that we are going to get it wrong when we do some of these restoration efforts. So we need to monitor them, and we have to be able to adaptively manage them. There has been great money for restoration implementation in the recent proposition funds that have come out over the last 5 to 10 years, but they do not often include monitoring funds. We can't learn from our actions if we can't monitor and continue to do the science. So that has to go hand in hand with doing, researching and studying, and then communicating it to everybody, including our school kids. So there you go. I'll stop now.
Thank you, Sarah. I would add to that in terms of monitoring, to experiment, like you said, to risk and do some experiments and be willing to fail so that we can learn from them and gain new techniques based on that.
I want to add one more thing that Virginia Gardner just wrote in, that we need to include the agricultural community and other aspects of the community. In the Sacramento, they're on it, as Jacob demonstrated. In the San Joaquin, I think we have more work to do to really have them be engaged and be on board. And so there's a lot of vision building that needs to happen in that part of the region. And it's like Sarah said, we can restore our floodplains till the cows come home, but until there's water to flood them, it's all very nice, you know. So I think that we have to bring in the people that are using the water.
Great. Okay. Well, so another key point of the whole symposium here is not just thinking about the watershed, but thinking on a much longer term time scale. So what do you see as, what are some of the opportunities that we could do to address and prepare ourselves, prepare the community, and prepare the ecosystems for longer term challenges, things that we could do over the short term that might have some important benefits over the horizon, the 50 to 100-year timescale that the symposium has really challenged us to think about. I think that's probably one of the most challenging issues. But any thoughts on that, on sort of how we work on a mix of timescales simultaneously?
I would like to put carbon back in the subsided delta, please.
Mm-hmm.
And figure, Lisa, you just figure out that methane thing. I think we can do it.
Yeah, Kurt Schmoody, I don't know, those of you who were here yesterday talked about floating islands as a possible way to get away from the elevation issues and incorporate some benefits. I think, novel ideas like that are really worth exploring now so that we could implement them. Lisa, anything you'd like to add?
Only just to say that I think we know what to do. I think we actually know a lot, and a lot of this is just action, and that the issue of uncertainty and people just issues of which is more priority or where do we have more confidence. And I think we need to be not afraid to fail and just go ahead and do some of these things and basically tell the story. And I think there's a lot of pride amongst Californians that live around the Bay Delta in this ecosystem. And so people, I think the story needs to be big, more spread about what's possible, and that there's alternative visions, and they're in keeping with some of the strengths as California citizens. So that somebody mentioned, we have strong economy, we have I'm trying to remember now. So with strong economy, oh my gosh, I've just blanked on it. It was the 30 by 30 talk yesterday. But the point is we can do all of these things together. And I think that we can talk about that as part of the story.
Great. Any other thoughts? Scott, you highlighted definitely sort of a mix of approaches, and I think that's the kind of thinking that we need to do, of sort of what do we do immediately and how do we set things up longer term.
Right, and that's right, that oblique, all those management actions there was intended to be, here's the ideal picture that we will have up and running decades from now. But in the short term, again, I guess back to the coordination piece, and we don't want to coordinate to death, but getting those, let's say at San Francisco Bay scale, just within our local tributaries, getting those that manage the upper watershed to coordinate with those that manage the lower watershed, that in and of itself would be a huge accomplishment, and that does need to happen ASAP. So we kind of look at it as a whole system, and then starting to put projects in the ground, like what is going to be coming soon down in the South Bay, where we are reconnecting creeks to a bayland restoration project, so that sediment gets straight out to where it's needed instead of having to be scooped and trucked as it's currently done. So this is all easier said than done. I get that for sure. We need the money and the permits to be able to do these things, but I think we as a region just keep highlighting within the San Francisco Bay in particular that sediment is becoming a commodity. It is a precious resource, and we need to figure out every way possible to get it onto our baylands where it's needed, or else it's going to start being used to build up pads for buildings in Silicon Valley so they can survive sea level. So we're really kind of heading that way with sediment. So we really need to get on our horse and get all the sediment management worked out at the watershed bayland scale within the bay.
Scott, I work up in the world's biggest sandbox, right? In the Yuba and Feather. We took them out, poured them down into the river. There's 14 feet of sediment over vast pieces of that landscape that now keeps the river down in its hole, right?
Yep.
And so much of the levee system that was built to get paddle wheelers from San Francisco to the gold fields was all built to move that sediment through that was choking transportation. Now we're starting to very slowly set those levees back. And what do we have access to? Huge amounts of sediment.
Yeah.
What can we do? Well, let's think about how these multi-benefit projects not only spread that water out, allow it to sink back in and recover aquifers that create this incredible kind of natural engine of productivity that I was talking about on food webs, but also are moving that sediment from places where it's stockpiled to where it's needed. And I think that we can definitely figure out how during either relatively frequent and what's the predictable regular flows, or during pulse flows, we can move sediment as part of this. So I'm so in line with that way of thinking. And I think that, again, we can talk in the abstract, and we tend to as academics, but we were talking about what can we do in the near term? Build Lookout Slough, build the first, absolutely landscape scale project in the Northwest Delta that can start to re-expose the tidal delta to long-term residence time tidal habitats. Let's put that notch in Fremont Weir that allows water, sediment, and fish to move back out onto the landscape and then down into the delta. Let's manage that, let's build the Nagiri project that acknowledges that once water gets out onto those floodplains, we have to manage the actual biophysical conditions of those aquatic habitats to mimic these processes so that we actually get a reestablishment of the ecological processes we're after. So again, I don't mean to sound like a broken record, but I think that we can do these projects and that is the most impactful thing that we can get done is act.
Thank you, Jacob. Well, so there's a question in the chatter on the mural that parallels another question I had about sort of prioritization. Given that we have limited funds currently, and there are all these opportunities for restoration, how do we go about sort of prioritizing restoration within the Delta, across the watershed, especially considering that what you all have been highlighting is restoration for a mix of benefits, not just for one particular thing. So how do we compare all these different opportunities and a wide range of different benefits? Any thoughts on how we could make some progress in that, in sort of prioritization? And
I think that we're doing a lot of it in the Sacramento Valley, working at scale, bringing together groups of people to do multiple big scale restoration projects. And I think we need to do more of that down in the San Joaquin, and working with the state parks or DWR, other large landowners, cities, municipalities that can reconnect. And we haven't talked too much about the headwaters and the fire. And ironically, that's a big source of sediment, Scott, and it's going to be coming down. And I made my talk to say, well, we need to really target, fuels management to reduce the amount of massive sediment loads that come and suck in the rivers. But we're probably going to miss some places, and maybe we could somehow take advantage of that. But it will be heading down to our reservoirs soon. As you pointed out, I don't know if you had included fire risk and increase of that in your model of sediment storage in the reservoirs.
Not explicitly, but yeah, we do acknowledge it as something that the Bay Area is just going to be dealing with more and more as time goes on. We've seen that in 2017 and 2019, and those years are just going to keep coming.
Yeah.
Any other thoughts in terms of sort of prioritization and how we compare across a mix of different projects?
I would just go back to your comment about multiple benefits. So highlighting and really planning for and trying to optimize multiple benefits. It has to be the way that we move forward. That we should actually not be doing projects that don't show the different ways that we are increasing connectivity, moving sediment, trying to restore functionality. All of those things that we've all been talking about. One question that came up in the chat and Q&A earlier was this idea of and floodplain, this all goes back to Jacob really with the floodplains, right? But we want to recharge groundwater aquifer. We want to provide floods to do geomorphic process for ecological reasons. We want to clean out and scour our rivers. So where are the best places to be able to put those floodwaters so it can do all of it, so that they can move sediment? There's a lot of ability for nature to do some of this work, but we need to help it do it. We need to figure out, and we have the science, we know, so then it's also part of just going ahead and making it happen, but really highlighting those multiple benefits and being smart about, where we can spend our money to get all of those actions together.
And I just want to make a pitch for this term that I think is good, called RIPMAR. We have AgMAR, FloodMAR. We need riparian managed aquifer recharge. So I just want to put that. That's like a classic place where we can have multiple benefits of recharging our groundwater and the whole 9 yards of what we've been talking about before: human connection, floodplain, habitat, etc. So RIPMAR.
Thank you. Any other thoughts on that?
Well, I'd just say,
yeah, go, Jacob.
Yes, please. I think that it's obvious that we have a lot of work to do in each one of our biomes, that we need to think about that in a connected way. We can, and we are. And I would point folks to the Northern California Water Association's their messaging around ridgetop to river mouth thinking in the Sac Valley. And I think that NACWA's done a great job of being a hub of bringing together conservation, ag, water, fishing groups, all different kinds of conservation, the major bird conservation groups, and everyone coming together to not just talk about what multi-benefit management is, but to think about it in each, from in our mountain meadows and forests, in our hydropower programs in the tributaries, into upper river side channel connection, in floodplain connection on the valley floor, in estuarine beach. All of that can come together in a way that actually brings the proponents of the different projects, organizes those projects, talks about their connections. In so doing, you have the frank conversations about what's actually shovel ready and what isn't. And you end up in a way where people all see how they fit in, they see where their projects are included, and they don't fight over who's going first to nearly the same degree. Those projects that make the most sense, that have the highest impact, that have the multiple dimensions and are ready to go are the ones that receive the funding and move forward, but we move forward in a much more coordinated way. And so I think I'm just reiterating exactly the story that we're telling here today, that the story that you guys put together in this session and having it organized in that manner. But I think that my short answer to you, John, is that we're doing it. We're doing it right now, and that we have to have the confidence to actually move forward with the action, with actually going out and putting that money on the ground and getting these projects built.
Great. Okay, well, we just have a few minutes left, and there's one question. Lisa Marie highlighted that we haven't really talked much about water quality issues, and there's some questions in the chat about pollutant issues related to this. Can we use pulse flows to impact harmful algal blooms in the Delta? Is there a synergy where we can think about how these sort of management actions or restoration would address water quality? So any thoughts around that one topic that we haven't got to yet?
I'll just say that we haven't talked too much about reservoir management. I know Sarah's talked about environmental flows, which is reservoir management. Yes, we want to be much smarter about that. And having those geomorphic, geofluvial flows that, blast things out, including a lot of the aquatic invasive species, I think is really important. And we need to, again, get that story across and make sure that we emphasize the importance of having those high level flows come through to do the sediment and the biological functions that they provide. I don't know if that answers your question, John. Yeah, it's just something that I think
that's. Any other thoughts to build on Amy's?
Just that so much of the water quality issues are flow related, and it's not just about, the solution to pollution is dilution. Let's just keep the flows up. We need these backwater sites for productivity as well. So I understand there's trade-offs and management issues, because again, we live in a totally managed system. I mean, it's like we can't just turn it all over to natural processes. We have to be involved, but the real framework for water quality, I mean, because that's what's driving most of these regulations. We have to be thinking about them in the long term, so that our short-term water quality goals are not inhibiting the long-term vision. So when we think about longer term, to me, it's easy to look at the really short-term issues of water quality
right now. But it's towards a larger goal. How can we manage the water towards that larger goal, which may lead to some not so great situations temporarily. So I think we'd have to think about time frame to the water quality versus larger geomorphic goals.
Great. Thank you all. I see Dylan has joined us, which means we're coming to a break. Yeah, again, I just want to thank a wonderful discussion and conversation. So I appreciate all the time that you all put into your talks, which I know is significant, as well as the discussion. So turn it over to you, Dylan.
Yeah, great. I think Lisa's time frame transition, different time frame, but on this shorter time frame, we're going to take a quick break. And I just really want to highlight how many excellent questions, comments, other projects came in during this session. And what I'm doing, what I'm dropping in the chat right now is a link to, this is also linked on our mural board, and we mentioned it at the top of our symposium, but I do just want to reiterate that we are hoping that, you know, this will hopefully become a series of related events where we can talk about these issues, because there's so much happening. And so, you know, you'll get follow-ups from us if you registered for the event, but also if you're specifically interested in follow-up activities, you can also visit the Google Doc that's linked here, and fill out a quick form, and that will kind of get you on our list to do any outreach. So we can bring up our break time slide now. We'll be taking a break until 10:50, at which time we will reconvene for our Visioning the Future panel. And just a huge thanks to all of our panelists from this morning, and John for doing a great job moderating. Really excellent conversation, and see you all in a few. Before we get started, Harriet, Nahal, and Charlotte, can you all just come on camera really quick and test your mics too? We didn't get you before we started.
Sure. Can you hear me?
Yes, can hear you. Thanks. Oh, and Brad as well, if you could just test your mic, I can see you.
All right, testing. How do I sound?
Gotcha. Thank you.
Yeah, new mic and new computer. So great. I'm happy.
Yeah. Good.
And can you hear me just fine?
Yep, we gotcha.
Great, thanks.
All right, great. Welcome back, everybody. We can go to the next slide now. I'm really happy to introduce our second session for the day today, moderated by Letitia Grenier from the San Francisco Estuary Institute, who you heard from in our plenary session yesterday. We're really excited to welcome Letitia back to help lead this conversation. I am just going to hand it over to Letitia to bring up our speakers and introduce the session. So thanks again to all of our panelists.
Thank you so much, Dylan. I'm really excited about this session. Wow, that was a great session we just sat through. I hope you were all able to listen to it. I really think the scientists who we've heard from are all saying the same thing. And what I heard was we need to restore natural processes. And we need to say that in a less jargony way than I just said it. We need to take advantage of flood, fires, and flows to put ecosystems back together so they can do things that are good for people and good for nature and wildlife. It's that simple, and that we need to get out there as scientists and tell that story better. And I will say, I think we agree the science is there. This is doable now. We can do it. And now it's a societal choice. And one of the choices we need to make as we're doing it is considering social justice. We could not go anywhere else in the world and say like, oh, we're trying to make these big changes to ecosystem, but we're not talking to the local people. That would be laughable and shameful. And, because we've learned that lesson over and over again in Latin America and Africa and Asia. And why aren't we doing a better job here? I think we are now. I think this idea has been recognized, but it needs to be woven in to all of the work we're doing. And the last thing I'd say is that I do think that the nonprofits and the more scientific government organizations are leading here, and that the implementers of the science in government are trailing. And it's clear, it's wonderful that this symposium was organized by the Delta Stewardship Council, a government agency, but we really do need to see some cultural change in government to catch up. And one of the big things I heard is we need to be willing to risk and to fail, or we are not going to get where we need to go. And governments really disincentivize that. And so I've been told many times, you're too pessimistic, you can't say that, you can't say fail, you have to say experiment. And I think it's really interesting. I was just reading a proposal for some scientists in New Zealand, and they had to say that it was likely that their science might fail or else they wouldn't be funded. In New Zealand, they want to see something so cutting edge that the government's going to pay for that it might fail, because they know that's what's necessary to move the needle. And so I'm really excited about this group of presenters who's going to talk now, because they're going to tell you the how. How do we do all these things that we just heard needs to happen in terms of the science and in terms of ecosystems? And so, oops, I'm scrolled down to the wrong spot. We're going to hear about how do you do this with permitting, planning, and implementing restoration. What do we do now to get toward those long-term goals? And what actions and frameworks are really useful for setting this up? Because it is this big, huge thing to tackle, and it's really hard to figure that out. And then how do we do these adaptation pathways? That's how I think of them. How do we make sure that what we're doing now is going to fit into long-term trajectories as well, so that we're thinking and acting at the short term, but also planning for the long term? And so I have some really fantastic panelists here who are going to talk, and they are all expert in a different angle of what we're going to talk about. And so I think I will just say who they are, and then each person is going to give their own introduction and talk about their area of expertise that speaks to this idea of how do we do this? Okay, we understand what needs to happen. How do we do it? Nahal Gogae from the Bay Conservation and Development Commission, Brad Henderson from the California Department of Fish and Wildlife, Harriet Ross from the Delta Stewardship Council, Jeff Mount from the Public Policy Institute of California, Charlotte Biggs from the Department of Water Resources, and Christina Toms from the San Francisco Bay Regional Water Quality Control Board. And I'm just going to skip the rest of my slides and go right to hearing from these folks, because I think everything that I was going to say has already been said very well by others. And so, Nahal, would you be willing to go first? Oh, sorry. Sorry, Jeff, go for it. I'm sorry, I messed up the order. Jeff, I think your slides come first.
Then you're going to have to back up. That's clearly not my slide.
Oh, okay. So I'm confused by the slides.
That's not it. Keep going one more.
Okay. Yeah. 3.
Interesting. That's not my first slide either. So
one more.
There we go. That's my first slide.
My apologies. I'm sorry, everybody.
I just, this reminds me, I hope next year we all can do this in person and just give each other a common cold. Wouldn't that be welcome? So thanks, Letitia. And I hope everybody got to see the first group, because I'm going to have some comments probably later as we go through our discussion about what the big key takeaways from that are. But I just want to sort of set this up as the cranky old fluvial geomorphologist. I think that's going to be my role today, who tends to think at scale. At large scale. So the big challenge we have ahead of us is trying to get at this question of scale. And I'm just going to make a couple of quick comments here as to sort of set things up before we go on to the others to introduce themselves. By the way, I'm Jeff Mount, I'm Senior Fellow at PPIC and retired professor from UC Davis. Next slide, please. There we go. So I just want to remind you what I heard this morning, which was reinforced. Remember that we are dealing with a spectacularly disconnected and simplified system. That is the terraforming we have done over the last 180 years. It is also hydrologically unvarying, which I think is extremely important to remember, thoroughly invaded, and indeed places like the Delta, where the bulk of the biomass is in fact non-native, and we've got a changing climate on top of it. So the point I want to make here is, let us be careful in what we're saying. We're dealing with novel ecosystems. We cannot restore what we had before. We're dealing with trajectories in novel ecosystems. Next slide, please. Thanks. So I don't need to dwell on this. Everybody on this knows what we're doing is not working. The primary approaches we're doing are relying on 50-year-old tools, the Clean Water Act and the Endangered Species Act, that risk-averse agencies take a very conservative approach to. Letitia already mentioned that. And the over-reliance in particular on Endangered Species Acts, I'll come back to that as we're having our discussion, is a recipe for failure in the way we're going forward. Next slide. In my section, I'm going to be sort of the minister of ecosystem-based management. I think this is with shifting away from single species approaches to basically ecosystem condition as the function, and which I include structure and function as what we should be managing to. And to do that, we are focusing on both native biodiversity and human well-being. And we're going to hear a lot about integrating humans into this thinking, which is, I think, something we don't do often enough. And that's going to be a highlight of what we're doing. And it is my belief, and Letitia is a co-author on this piece we wrote at PPIC on this leads to net greater benefit and reduces conflict. Next slide. So the key on ecosystem-based management, and remember, you are managing toward basically function as much as anything else, and we're going to hear a lot about that, but it is ecosystem condition that we're working toward, not the life history strategy of a single listed species. That's key. And of course, in all of that, you heard Sarah Yarnell give a wonderful talk on functional flows this morning. It is restoring that function which is necessary. It is dealing with the fact that we have disconnected this landscape so dramatically in all dimensions. I mean, longitudinally to the upper watershed, laterally to the floodplain, and vertically to groundwater. So it's reconnecting. That is the only way you're going to get the most efficient use of your flows. And of course, this means we have to conjunctively manage both habitat and water quality. And we're in it forever. We are in it. We are in the conservation management of our native species forever. They're never going to be able to just go on their own and be just fine. We're going to constantly be messing in it. And finally, the last takeaway that I have here is that this is my mantra. You cannot do ecosystem-based management unless you do it at the watershed scale. And of course, that's critical for reconstructing it. And then, by the way, I'll throw out a wild ass idea while we're here. Give the environment a water right and allow it to manage it like a water right. And this is going to make some heads explode, but that's what I'm here for. Thanks, Letitia.
Thank you so much, Jeff. My head just exploded in a really happy way. I love that idea. I think that would give benefits to a lot of us. So I think Jeff did a great job of setting us up in terms of thinking about at least how a cranky geomorphologist, who I think is right, thinks about how should we fit it to bring these benefits. And now I'm going to go to Nahal, who has a lot of experience actually bringing in the social justice piece. How do we hear from all the voices that need to be a part of setting the priorities?
Great. Good morning. My name is Nahal Gogai, and I'm joining from Ho-Chunk Territory here in Berkeley. Thanks so much to the Delta Stewardship Council, and especially to Letitia for inviting me to join this panel to share about my work leading the San Francisco Bay Conservation and Development Commission's Environmental Justice Program. I've devoted over a decade of my career to the pursuit of the rarest resource that O.B. Kaufman discovered during his walkabouts throughout the state, which is our ability to talk to each other. I've committed to finding ways to foster meaningful and solution-oriented conversations and partnerships between government, academia, industry, and underrepresented communities. I started this journey supporting the Salish tribes in the Puget Sound with climate adaptation pilot projects located in the upper Snohomish and Nisqually watersheds to ensure reliable stream flow timing for salmon habitat protection. Fast forward by about 11 years, and I find myself even more committed to environmental justice and supporting community leadership in equitable climate adaptation planning in the San Francisco Bay Area and across the state of California. As a water equity and environmental justice advocate who has primarily worked from the community side at nonprofits and as an independent consultant, I made my foray into state government when BCDC created an environmental justice role. I became the agency's first ever EJ manager over 2 years ago to spearhead the implementation of what was then the recently adopted EJ and social equity policies. Next slide, please. My apologies in advance for the text-heavy slides. I'll run through them quickly in order to make sure other panels have time for their introductions. So back in December of 2019, BCDC adopted our EJ and social equity policies, which apply to our permitting process. The Commission also adopted a set of guiding principles that apply to all of our programs. The policies focus on early and often meaningful engagement with local communities, fair treatment and consideration of disproportionate impacts, as well as equitable public access. And the guiding principles start with the recognition and acknowledgement of Native American tribal communities and connections to natural resources. The principles also commit to accountability, transparency, and accessibility among the list of other equity commitments. Next slide, please. The policies apply to permits for major projects and appropriate minors located in or adjacent to underrepresented communities, which we identify using BCDC's Community Vulnerability Mapping tool. We believe community involvement results in multiple benefits, including establishing trust, more innovative designs and sustainable projects, as well as building community capacity. Next slide, please. One way that the agency has prioritized community capacity building has been through our EJ Advisors program. As a strong believer in the value community representation brings to all stages of planning and policy processes, I didn't feel I could develop a robust policy implementation strategy without the guidance and leadership of Bay Area EJ community leaders and equity experts. So I hustled hard to secure funding from our partners at the Resources Legacy Fund to ensure that we could offer compensation to our future advisors. Once the funding was confirmed, and after reviewing 30 applications and conducting interviews with 27 of the 30 applicants, we recruited BCDC's inaugural group of 6 EJ advisors. I want to make sure to recognize them by name and by their community. So I'll just start at the top left and share their names and community. Violet Sienna represents East Palo Alto and San Mateo County. Maribel Tobias, up on the top right, is from Richmond and represents East Oakland and much of the East Bay. Julio Garcia is also from San Mateo County and is working in South San Francisco. Selena Feliciano is from West Oakland. Anthony Khalil is in Bayview Hunters Point. And LaDonna Williams represents South Vallejo and Solano County. These 6 leaders have been helping BCDC develop an EJ policy implementation strategy since April of last year. Please feel free to check out their bios and the group charter on our website at bcdc.ca.gov, and it's under the EJ section of the planning tab. Next slide. The EJ advisor's top priority is to develop an EJ and permits workshop that will help build their capacity and understanding of BCDC's permitting process through the review of relevant case studies. This workshop will include a discussion with regulatory staff about possible improvements to the process, and outcomes will be captured in a suite of tools that will provide guidance to staff and permit applicants on best practices for meaningful engagement and equitable project design. Please stay tuned for more on this effort in the spring. Thank you.
Thank you so much, Nahal. I think that really goes a long way toward answering the question of how do we include communities and center their needs in our work? And this is focused around BCDC, which has a regulatory approach and not as much about restoration. But even if you've got a restoration mission, it's a very similar way, I think, that you can bring communities in and really center their voices and partner with them from day one of the process. So thank you so much for that. And now we're going to hear from Harriet, who I'm excited to hear from as another government official who can tell us how is the Delta Stewardship Council thinking about these issues.
Great, thank you. Again, I'm Harriet Ross. I'm the Assistant Planning Director at the Delta Stewardship Council. Just a little bit about me. I'm an environmental scientist and land use planner by training. Been working on planning issues all over the state, mostly working for local governments for many years before coming over to the council about 3 years ago. Next slide, please. And as Letitia mentioned, I'm going to talk about the council's planning efforts on ecosystem restoration and how we're really looking at adapting to changing climate conditions. We're currently preparing the final EIR on an amendment to Chapter 4 of the Delta Plan. Very exciting to get to this point in the process. And the ecosystem amendment really provides high-level guidance on the scale of restoration needed for a functioning, resilient Delta ecosystem. And it also identifies restoration targets and appropriate elevations for restoration to occur in order to accommodate sea level rise in the future. Our other main ecosystem planning effort related to climate adaptation is Delta Adapts. And I'm really going to focus my part of the discussion today on that initiative. Delta Adapts will provide the information really needed to operationalize action and identify adaptation strategies. Next slide, please. And for those of you that haven't heard me present on Delta Adapts, I feel like that's what I've been doing the last few years here. Delta Adapts is the council's comprehensive climate change study, has 2 phases. We finished the first phase last year, and that's the vulnerability assessment, which really identifies the climate impacts the Delta and Sassoon Marsh are vulnerable to. And then we kicked off the second phase to prepare an adaptation strategy late last year. Next slide, please. The vulnerability assessment took about 2 years to complete. This was developed through an extensive engagement process. In fact, we had over 70 briefings and meetings with stakeholders right around the time the draft vulnerability assessment was released. And this engagement really included a number of components. We launched a significant effort to outreach to community-based organizations who helped us structure our engagement to reach vulnerable communities in the Delta. And we identified the most vulnerable communities in the Delta through our equity analysis and focused our outreach in these areas. We contracted with a few organizations and held 2 public workshops in Stockton last year. We also worked with community-based organizations in the city of West Sacramento and held a joint climate workshop with the city that covered their climate change efforts and our adaptation work. And since then, we've engaged and contracted with 5 organizations and tribal representatives to help guide us in addressing environmental justice and equity for Delta Adapts and other initiatives at the council here. Other outreach efforts included ongoing collaboration with our agency partners. We had a series of stakeholder briefings where we met with folks to really ground truth our data and verify our results. We had a technical advisory committee, and we also have a stakeholder work group really consisting of local agencies, some state agencies, environmental groups, just a whole host of folks that are really helping provide data and input into our assessment and our process. And as we move forward and through the adaptation process, we're hoping to continue this level of engagement, though it looks a bit different. And for the next slide, before I talk about our adaptation approach, I wanted to go over quickly our goals for adaptation strategy, just to give you some context and probably for the discussion later on. First and foremost, we want to protect the state's interests, achieve the council's co-equal goals. And of course, the adaptation strategy needs to be consistent with the Delta Plan itself. We also want our adaptation process to help inform decisions about trade-offs of implementing different adaptation approaches. And we're really seeking balance between adaptation. Obviously, we can't protect one interest over another in the entire Delta. We really have to balance the needs of varying interests. We also need to consider the differences in climate vulnerabilities within the Delta. And lastly, we want to make sure adaptation occurs in an equitable manner and is prioritized in the Delta. So just really quick on the next slide here, it's just a quick overview of our adaptation process. We'll be organizing the Delta into subregions and looking at Sassoon Marsh separately. The council's adaptation strategy will focus on 4 technical topics that are in line with our regulatory authority, and that includes flooding, agriculture, ecosystem, and water supply reliability. We formed focus groups for each of these topics, and those members are helping us identify different adaptation approaches by subregion. And we'll be taking these critical components of adaptation by topic to form 3 landscape-wide scenarios for consideration. We will then evaluate those scenarios against the metrics that we define with our focus group members. And then based on these metrics, we'll be identifying trade-offs of implementing one scenario over another. And through this process, we hope to land on a preferred scenario and work with these focus groups to develop adaptation strategies. And so the overall adaptation strategy will include a range of actions that likely others will implement. We'll be identifying costs of adaptation, who will implement it, and a general time frame for implementation. And that's it for me, just setting it up for Delta Adapts. I'm looking forward to the discussion. Thank you.
Thank you so much, Harriet. I really appreciate the clarity of what the process is there and the emphasis on engagement and equity. I think that's exciting to see that approach. And now we're going to move on to Brad, who's going to talk about some exciting new approaches that have been happening in terms of thinking about permitting and how to help move forward restoration projects.
Great, thanks Letitia, and thank you all. I'm Brad Henderson, and it's great to be here today. I started my new job as the first program manager for California Department of Fish and Wildlife's new Cutting the Green Tape program just on November 1st. Before I start, I just want to acknowledge, we have a biodiversity crisis, a climate crisis, and we need to act now. You'll probably hear the urgency in my voice as I give this presentation. What do we need to do? Well, we need to come up with habitat restoration projects that are bigger and better and get them on the ground much faster. We're supporting this by creating improved granting procedures, new tools for environmental restoration permitting and CEQA, and establishing a team of dedicated restoration experts within the new program. Since there's no time to waste, next slide, please. And just really quickly, cutting the green tape establishes a new multidisciplinary team focused on a unified approach to supporting restoration through granting, environmental review, and environmental permitting. This is a unique and non-traditional program for CDFW. It's housed within our Water Restoration Grants branch. We're the ones who give out money for Prop 1, Prop 68, and FRGP. So that's a real change for us. And today I'm going to introduce how our preliminary efforts to accelerate restoration can help projects both small and large, and especially how this initiative can support and encourage larger, better, and longer term projects. So I won't go through these bullets, but this does provide a good summary of what we're up to. Next slide, please. And so what's happening right this moment? We're in the midst of hiring. We're building our team. I was just recently hired for this job. We're investing in the new staff. We're trying to develop a culture of restoration, if you will. We're developing the program. We're continuing our engagement efforts with stakeholders. We're working on websites, workshops, and stakeholder feedback is really helping to inform our priorities and where we go next to help clear a better permitting pathway for projects, and especially larger projects. And so a couple examples of what we're up to, we have a couple of new permitting tools that address take authorizations. This includes a new permit called the Restoration Management Permit. I'll show you how that works in a second. And the Restoration Consistency Determination, or Restoration CD. We're also administering a brand new CEQA statutory exemption for restoration projects. We completed our first pilot over the holidays. We've got other projects in the queue, and you'll see some coming online soon in terms of getting our concurrences posted. So let's take a moment and look at 3 project permitting strategies using some of these new tools, from very small projects to very large projects. Next slide, please. So this is called the Paynes Creek Project. It's just a small water diversion. You can see the kind of fuzzy picture on the left. It's a flashboard dam, obviously prevents fish passage in a tributary to the Sacramento River. The project is getting rid of that dam and replacing it with what you see in the upper right, which is a roughened channel, which elevates the water surface to still allow for the water diversion while providing fish passage. And then the lower right picture shows the other part of the project. It's a cone screen. So this is a very small project in terms of acres, but has a large impact because so much habitat above was inaccessible. And for reasons not worth getting to at this moment, the project was deemed ineligible for a small habitat restoration 401 pathway. So instead, CDFW was able to use a different pathway, and this is what we call the Restoration CD. NOAA Restoration Center has a Central Valley Office programmatic biological opinion for restoration projects, and we were able to create and actually execute a new type of consistency determination using that document. And the CD covers take that would occur during the project of winter run and spring run Chinook salmon. The CD was simple. It works really well with the small habitat restoration CEQA exemption, and there was no fee. So small project, quick solution, big impact. Next slide, please. Here's a little larger project that's really different. This is a larger site. It's a 20-acre pond in a meadow in Southern California. Yes, there are meadows in Southern California in the San Bernardino Mountains. And this site just happened to be the perfect place to create a refuge for 2 very endangered species, Southern mountain yellow-legged frog, which is CISA listed as endangered, and unarmored 3-spined stickleback, which is also listed as endangered, but also fully protected, which is another category that can be hard to permit. The landowner is the Wildlands Conservancy. And basically this permit allows for the agencies, Fish and Wildlife Service and CDFW, to translocate these species either from habitat or captive rearing facilities into this little pond. And the Wildlands Conservancy would conduct species management, including ranger patrols to protect the habitat. They would conduct invasive plant and animal management and provide support for the agency's monitoring and management for the long term. So in this case, the Restoration Management Permit provides take authorization for long-term management and no fee. Next slide, please. Big project, in fact, massive project. Redwoods Rising. It's a partnership between Redwoods State Park, Redwoods National Park, and the Save the Redwoods League. And this is an example of a long-term multi-project restoration management permit, which avoids the need for having to issue separate permits covering each phase of the long-term and watershed-wide project. Next slide, please. So what are we talking about here? This is huge. It's 80,000 acres in 2 watersheds, Greater Mill Creek, Greater Prairie Creek. Some of the features of the project are to rehabilitate a very large area of second growth forest in the 2 parks. And this is really having to do with legacy timber harvest impacts. As you can see in the pictures, there are plantations, there are whole streams that are buried with debris. And so also there's 300 miles of abandoned and failing logging roads that would be removed, removing all this debris and putting the wood in places where it will help the covered species. And what are the covered species? There's a lot of them. We've got 6 California Endangered Species Act listed species, 1 CISA candidate, and 5 fully protected species for a total of 12. And a lot of work went into this, obviously. There was CEQA, there were federal documents authorizing take, a lot of work by the parks and the partners, but in the end, our permit was only 18 pages. Next slide, please. And so our new project is still getting up and running, but we're here to help you. We want to hear about your project. Come talk with us. We have a new webpage, which is just barely going, but it's there. We've got regional contacts who've been hired. We have me and my staff in headquarters. Get in touch, come talk to us about your project, and let's figure it out. Thank you.
Thank you so much, Brad. It is really exciting to hear about that. I see CDFW shaking off that reputation of challenging to work with on permitting. So let's hope that continues. Really appreciate those examples. And now on to Christina Toms. I can't see you on my screen, but I know you're here, who's going to talk about this from the perspective of the Regional Water Quality Control Board.
Sure, super. Thanks. Good morning, everyone. Happy to be here. My name is Christina Toms. I'm an ecological engineer and senior environmental scientist with the San Francisco Bay Water Board. If you've never heard the term ecological engineering, all of my degrees, my whole background is in engineering, and it's the integration of ecology into every step of the engineering design process. So I really come to these challenges with a background of looking at the interactions between physical and ecological processes. I spent 12 years in the private sector as a primarily estuary and wetland restoration design engineer, worked for Wetlands and Water Resources and then ESA, and then came to the Water Board. And I'm our lead on all of our efforts related to multi-benefit wetland restoration in our estuaries and climate change adaptation. So my portfolio broadly includes a lot of science and engineering and policy. And I am a government official, but I'm also a Philadelphia sports fan. So I do consider failure to be a crucial part of the process. So just want to be clear about that. Next slide, please. So if you've never heard of the Water Board, I apologize. And also, how is that possible? But we pretty much, if it's wet, we regulate it. So we regulate a broad range of activities related to the conservation, management, and restoration of aquatic ecosystems, both upstream in watersheds and downstream in estuaries. Next slide, please. So we're making some pretty significant investments in the science and policies that are necessary to support healthy, diverse, and resilient landscapes in the San Francisco estuary and along the outer Pacific coast. And I want to briefly describe some of them here before we jump into our panel discussion. Next slide. So first off, we're developing a series of amendments to our basin plan, which is kind of like our regulatory Bible. Those amendments are going to address the threats that climate change poses to the quantity, the quality, and the beneficial uses of the wetlands and waters in our region. The first of these amendments clarifies existing policies that regulate dredge and fill activities with a special focus on the interactions between climate change and activities in coastal, estuarine, and nearshore waters. Next slide, please. So this amendment is going to describe a series of factors that applicants should consider when applying to the Water Board for a permit. This includes the science upon which the proposed actions are based, if these actions are developed within a long-term landscape scale framework, if they utilize appropriate nature-based design approaches that emphasize physical and ecological connectivity and complexity. I feel like there's one message that we've heard over and over the last 2 days. It's that nature likes mess, and we want to facilitate that. And we also want folks to address impacts and mitigations within the uncertainty, the uncertain context of climate change. I'm leading the development of this amendment. We expect to have it out to the public later on this year, hopefully this spring. Next slide, please. So we funded the first phase of the San Francisco Estuary Institute's Adaptation Atlas. The Atlas provides a cross-jurisdictional framework for climate change adaptation planning and proposes where along the Bay's shoreline certain nature-based adaptation approaches may be appropriate. We're continuing to fund and provide technical support to future phases, ongoing phases of the Atlas. These phases are going to clarify how we deploy those nature-based approaches, how we integrate them within phased adaptation strategies, and how we do that to support specific ecosystem services that benefit both the natural and built environments. Next slide, please. So of course, the Water Board is a participant in the BRIT, the San Francisco Bay Restoration Regulatory Integration Team. This is a group of dedicated funded staff from all 6 regulatory agencies in the region with jurisdiction over wetland restoration and shoreline protection projects. It's partially funded by the San Francisco Bay Restoration Authority, and it's accelerating restoration project permitting and developing consistent procedures for early project planning and review. Just to be clear, I'm not the Water Board's representative on the BRIT. That falls to my colleague Agnes Ferris, but I do provide senior technical review and backup to her and to other Water Board staff that interact with the BRIT. Next slide, please. And so finally, the Water Board is one of the lead agencies developing the San Francisco Estuary Wetlands Regional Monitoring Program. And this is an effort I'm really proud of. It's a hugely collaborative program that involves pretty much all of the agencies and stakeholders that are participating in the symposium in the estuary. Climate change, as we've heard over and over, it operates on a landscape scale across a broad scales of space and time. And so in order to understand how it's impacting the region's tidal wetlands and wetland restoration projects, we really need to monitor the processes and conditions in these wetlands across a similarly broad range of temporal and spatial scales. This approach is a real pivot away from how most monitoring has been and is being done in the estuary. A lot of it is project driven. A lot of it is driven by regulatory requirements and performance measures. And by taking this more transdisciplinary landscape scale approach to monitoring, we really think that we're going to hopefully develop information and not just data. We have a lot of data, but we don't have a lot of information. So we're building the WRMP around a series of key management questions and information needs for the estuary's tidal wetland stakeholders, such as where are the wetlands, how are they doing, where are they keeping pace with sea level rise, where would certain types of interventions help support, again, this landscape scale complexity and connectivity, and how can we help these ecosystems persist into the future, like 20, 50, 100 years down the line. I'm chair of the WRMP's Technical Advisory Committee. Donna Ball from SFEI is as my co-chair, and we're working really closely with our partners in the Delta to really align the science content of the WRMP with the tremendous amount of science that's being done by the IEP and the Delta RMP and all the other huge monitoring efforts that are going on in the Delta. Next slide, please. And so if you'd like more information, here are some links, and I look forward to our discussion.
Thanks so much, Christina. That was fantastic to hear about some of the forward-thinking work that the Water Board's doing. And the thing I really heard in there was we have a lot of data, but we need more information. And I think this is an ongoing problem across the whole estuary, including the Delta, especially when we look forward toward climate change. We have data, but I'm not sure we've turned it into answers to our questions. And so last but definitely not least, we're going to hear from Charlotte, who perhaps has the hardest job of doing the actual real on the ground implementation of restoration projects. So we're really excited to hear about Eco-Restore.
Yeah, good morning, everyone. I'm Charlotte Biggs. I'm a program manager with the Department of Water Resources. And the program that I manage is called Eco-Restore. So the Eco-Restore initiative is a multi-agency initiative that was started in 2015 to advance at least 30,000 acres of critical habitat restoration and enhancement within the Central Valley. And that includes the Delta, Sassoon Marsh, and Yolo Bypass. So my department, DWR, we lead Eco-Restore, and we are the implementing agency over the majority of the efforts within the portfolio. CDFW also leads some projects, and we have lots of other partners as well that we collaborate with, which I'll elaborate a bit on later. So yeah, my perspective today on this panel is more on the ground. I'll provide some insights through my experience working to plan and construct restoration projects within the Delta over the last 10 years of my career. Within Eco Restore, while our initial goal that we set in 2015 was to restore 30,000 acres, today we're actually tracking about 40,000 acres of projects when you count everything that we have in planning. And we're continuing to add to that portfolio every year as we continue. So the map on the screen, I don't have a lot of slides. This is the only thing I brought today, is a map showing all the locations of our projects. We're tracking about 32 projects at the moment, although I have 2 more I need to add, so it's a little bit out of date. And I need to update some of the timing, but this still gives you a really good idea of the scale and the locations of the type of work that I'll be referencing today. So I wanted to kind of update you on how our progress so far. The program again started in 2015, so that was about 7 years ago now. So to date, we've completed, so we've constructed and we are now adaptively managing and monitoring 10,000 acres of habitat restoration within the Delta Sassoon Marsh and Yolo bypass. Within that includes about 5,500 acres of tidal wetland habitat specifically. We have another 2,000 acres that are currently under construction and will be completed over the next several years. And what's really exciting is that we have about 20,000 acres that we're hoping will be breaking ground later this year. Some of these projects I heard mentioned earlier this morning. So projects that we are hoping will start construction soon, part of this 20,000 acres are Lookout Slough, which is a landscape scale tidal wetland restoration and flood improvement project, as well as the Fremont Weir Big Notch, which will create about 15,000 acres of seasonal floodplain within the Yolo bypass to benefit juvenile fish such as Chinook salmon, and some of what I heard Jacob Katz talk about this morning, the type of floodplain restoration, seasonal floodplain restoration. So about half of our projects that we're working on are done to offset state water project mitigation requirements. And the other half are related to the flood and levee system. So they aren't mitigation. So we're about half and half in terms of mitigation and non-mitigation in our funding sources as well. Some of our projects actually predate the program. For example, an effort that we just completed last year in 2021, Dutch Slough Tidal Habitat Restoration Project, which is about 1,200 acres of tidal wetland in the Contra Costa County. That project was in planning for 20 years, over 20 years. So historically, these projects have taken many, many years to complete, which is why we really established the Eco Restore initiative. We needed a framework to help incorporate lessons learned, offer technical support, tackle more of the programmatic challenges, such as planning adaptive management, considering sea level rise, and also just to do outreach. A lot of my job is doing outreach, giving talks like this, creating videos, putting more information out there to try and tell our story a bit better and create more awareness around especially DWR's work in restoration and why it's so critical, so that we can hopefully generate more funding for this type of work in the future and more support. So again, Eco Restore is really a framework, and it was built on the assertion that cutting edge science, strong partnerships, and a healthy impatience could drive more restoration than had ever been pursued in the Delta. And I'll say this again later during our discussion. I'm really proud of the work that we've done to date. 10,000 acres is more than we've done in the past, but we still have a lot more to do. And we acknowledge that. We really needed to start somewhere. We needed to start demonstrating success, get projects on the ground, provide those lessons learned, demonstrate proof of concept in order to gain more support and do more. And that's really the way that I look at it. Later, I guess, in the discussion, I'm going to elaborate a bit more on our evolution from where we started, which were smaller, more single species types efforts, to where we are now, which is much larger, multi-benefit projects where we're utilizing a lot more partnerships, and then what the future hopefully looks like. And to me, more importantly than what the future looks like, I want to discuss what I think is needed for us to get there, especially from my perspective of being kind of on the ground and dealing with some of the constraints that I see firsthand. So thank you for having me today, and I look forward to discussing this more.
Thanks so much, Charlotte. It was great to hear that and great to see this trajectory. When I started I'm going to meetings about the Delta 15 years ago, I'd say the wheels were not turning on this cart at all. And now they are. And hopefully we're gaining momentum in the way that you're describing. So I just want to point out across that group, we heard that governments and others are implementing the kinds of ideas that we've heard the scientists say. I did not hear Governor Newsom come on and say, Letitia, we've reorganized restoration around watersheds and ecosystem-based management. And I'm hoping he's going to do that because I do have a big birthday coming up. But let's not wait for him to do that. Let's move forward on all these great ideas that are happening and are moving through our system right now. And I'm going to start with a couple of big picture questions. We have some great questions in the chat that we're going to bring forward already. We've got about 25 minutes to converse with our panel a bit more here. So I'm going to start by turning back to Nahal, and I'm going to say, if you could change one thing about how restoration happens, and I know you're working more on the regulatory side, but restoration projects do go through BCBC as well. What would you change about the way the system works?
Thanks. I think that, as I mentioned in my intro, I really think that we should prioritize relationship building and building capacity. I think, having teams ready to work with communities, but it really requires them to become well acquainted with community leaders first. I just have seen too often that groups of restoration professionals will work together on a project design for months, maybe years. And then at the very end, they'll scramble to find a community or tribal partner. Often it's for extra points on their proposal score, which is pretty obvious the way that it happens. And so often the community leader's contribution isn't considered until the last minute. And this fact is pretty obvious when you look at the budget. So this is pointing out the fact that capacity building is a two-way process. We don't need to just focus our efforts on building community capacity to engage in these climate adaptation and restoration projects, but really we need to work on our side as well, on the other side, to build our capacity to change the process to be more equitable and respectful towards community and tribal experts that'll greatly contribute to your proposal success and the project success.
Thanks, that's such a key point. We are used to these transactional approaches where we ask somebody to be part of a team to get a project going, but we really need to have long-term relationships. And those are hard to fund, but we've got to figure it out. That's really fundamental thought there. Jeff, I'm going to ask you the same thing because I know you've thought about this a lot and you've thought about it in terms of legislation and policy. What's the one thing you would change around how restoration happens in California?
I only get one?
You have to. Yes.
It's a struggle to keep it to 5.
Okay, you could have 3.
No, it's perfectly fair, Letitia. And there are many things. Fundamentally, and this is not intended to be hurtful to members of our group here, but we have, solidly in our agency DNA, a risk aversion. Nobody wants to get in trouble. And so, and then everything we do in our agencies discourages risk taking, despite people like those on this panel. So we need leadership at the state and federal level to allow agencies to be experimental and to take risks and to not lose a career because something goes wrong, because we cannot, and I'm going to add one more thing, which is related to that. When I listened to this morning's talks and some of yesterday's too, what I kept saying was, okay, we know this. We all know this. So Jacob Katz basically got it. We have to now do this. Stop talking and do this. And I think we've hit a place, and this is going to be harmful to maybe Laurel and others, where we're not seeing big leaps in understanding and the science to support all of this because we haven't gotten out there and taken the risk of doing these large projects at scale. Once we do that, I think we're going to see a renaissance in science and restoration once we get out there and get these big projects together. But yeah, frankly, I know that was more of a social commentary rather than a scientific commentary. Yeah, we have to have risk taking. We got to take risks to reduce risk. And that starts with the legislature, the governor, federal folks saying, it's okay. I'm not going to fire if you make a mistake.
Thank you very much. I appreciate those big picture thoughts from both of you. And now there's a lot of questions in the chat around permitting and bureaucracy and, how do we make things move faster? And I want to bounce off one that Evan proposed to Christina, and I'm going to generalize it just a tiny bit to the way I think about it, which is that transition zone, which is sort of a code word or jargon for where the estuary is headed. So as sea level rises, our coastal areas are going to move upland, uphill, and those spaces aren't, as far as I know, protected by the Clean Water Act. And so how is the Water Board thinking about that and considering that in the Basin Plan Amendment or just in your interpretation of policy in general?
Yeah, I think that's a really great question, but it's a question that's really linked to broader issues, which is that we are our activities and our decisions are enabled by our governing legislation and things like no net loss, which is a governor's order. We can't adjust that through our basin plan, but we can be clear about how we're interpreting it and applying it on the landscape. I think particularly when it comes to landscape scale restoration and creating space for marsh migration and creating space for floodplain activation and for these physical processes to really exert work on the landscape. I think something we have to keep in mind is that a lot of restoration in the past has really been opportunistic. It's been driven by these site-specific opportunities, by public agencies and nonprofits being able to acquire whatever properties they could that had willing sellers. And so that was fine for a while. We did make some restoration progress, but a lot of that low-hanging fruit has been picked. And so, and if you'll bear with me, I actually wrote this out because I wanted to make sure I made it clear. I didn't want to ad-lib this. The remaining priority restoration projects, by definition, are going to take longer and be more expensive to implement because they've got land use constraints, they've got infrastructure, they've got flood management complexities, they've got proximity to developed lands, and other confounding factors. A lot of the projects that Charlotte just brought up, Eco-Restore projects, they predate Eco-Restore. Hill Slough was held up by needing to raise Grizzly Island Road. Dutch Slough was held up by needing to encase the Contra Costa Water Canal. We're hitting into these projects. We're having problems with project implementation, partially because we have permitting challenges. And I appreciate Brad bringing up the cutting the green tape. There's definitely some opportunities to streamline permitting, but all the permitting streamlining is in the world isn't going to fix the fact that our restoration planning isn't aligned with how we're planning and managing the built environment. And so until we really align these processes that are, the Caltrans people that are making decisions about highways, what the railroads are doing, what we're doing with our water, infrastructure. Until we align those with landscape scale restoration plans, we're going to get more. First of all, we're not going to get the restoration that we need to do, and we're going to get more Newark Area 4s. Newark is proposing to put 457 units of luxury housing in diked baylands that really should be transgression space for tidal wetlands, right? And so we've got tools like the Adaptation Atlas, we have tools like the landscape planning scenarios that you've worked so hard on that can help us figure out how to align restoration with these broader planning processes. And we've got some piloting approaches where, what Caltrans and other stakeholders are doing with regards to Highway 37. There's the one shoreline effort in San Mateo County. We're trying to figure out the governance structures for what it looks like when we align these processes. But until we do that, we're going to keep on hitting our heads against the wall, and we're going to keep on focusing on opportunistic restoration instead of landscape restoration.
Yeah, thanks for that honesty, Christina. I think that is a huge problem. And right now we really rely on our sort of advocacy nonprofit partners to fight those battles. But it would be great if we could have better alignment with local government and transportation agencies, just as you're explaining. I think that's really valuable. So lots of questions about permitting. And Brad or Charlotte, I want to pitch this one to you. What's your advice? So how, a lot of the permitting issues that we see out there, or a lot of the permitting facilitation approaches that we see out there don't work very well for big, complicated projects, especially the kind that Christina's talking about. Do you have any advice for project proponents who are trying to put something like that into the ground? I'll start with Brad.
Yeah, it's probably not anything unexpected, but let's talk early. And I want to just just disclose that we don't really have, or we haven't had great tools for those kinds of projects for a long time, and we're just now kind of on the verge of developing them. One of the new permits that I mentioned, one of the things that we realized right away as we were talking about it was that a lot of these more complex, larger projects are not the kind of thing where you come in, you put in your restoration installation, and then you disappear forever. These things require constant maintenance, constant management, monitoring, and that could go on indefinitely. And so one of the things that we are really keyed in on is when we're talking about any restoration project at any scale is what are those needs? What are the long-term monitoring needs? What are the long-term management needs? Repairing sites, tweaking sites if they're not working, adaptively managing all those kinds of things. And so I really hope that we are going to be able to start discussing these larger landscape level projects as early as we can, and we start building the tools that we need to make sure that they're successful. And if we don't have those tools, then we need to start creating them.
Thanks, Brad. Charlotte, do you want to add anything to that as someone who's dealt with this?
Yeah, I can try. I'm excited about Brad's program of cutting the green tape, and excited to see that become more real, because there is a lot of green tape and there's red tape in terms of implementing restoration projects. And I think I agree with so much of what Christina just mentioned. I'm the lead for our largest wetland project right now. It's a multi-benefit project and it's very complex. And I will say that the reality of working through permits on these projects is there isn't a lot of flexibility. And what's needed for one agency can conflict directly with what's needed for another agency. And that's the reality of where I've been for the last several years. And trying to negotiate between those different agencies that you have to sort of be the middleman is not always the most productive conversations. I think that even with leadership at those different partners buying in on the project, understanding that the project's important, understanding that the outcome of the project is needed, it doesn't seem to result necessarily in, easier time getting it implemented or through the different approvals that are needed. And so we need to figure out a way to translate that big picture buy-in on what's needed for the ecosystem, what's needed for the species, what's needed to protect public safety in terms of flood, and translate that down into what we write on a sheet of paper on a permit and how those terms get negotiated. Because in the Delta, there are complications, I don't even want to get into, but for example, trying to do off-site mitigation as close to the project as I could for a species required negotiating with 42 landowners that are in one trust owning the property next door. So getting a piece, a template approved by 42 people, family members, is the kind of reality that I think that I'm living. And we need to be flexible. And what happens is if that template wasn't exactly right, it doesn't, my sister agencies sometimes aren't able to even accept it. And we have to go back and renegotiate that type of thing. And that's the type of thing that we need to figure out how to work through so that we can, save some time. I think that the reality of doing these types of projects, you are going to end up owning the property, whether it's the state or through a partnership, which I think we're getting a lot more innovative in how we're partnering to get these types of projects done. Public-private partnerships, really can help us move things along a little bit quicker because there's more flexibility on the private sector than the state might have, especially to acquire land. So we can look at, less about, whether or not we're able to find the value in restoration right up front and define that, and instead work with someone that owns a piece of property that's willing to work with us. But that person or that entity needs to hold on to that property the whole time it's going through permitting. So if we're talking about 20 years, that's a lot of land management, a lot of assessments that are paid. There's a project that I know my project manager's on the line today, McCormick Williamson tract, where it was owned by the Nature Conservancy, and they got to the point where it had just gone on far too long for them to hold on to that property anymore. We hadn't, been able to build the restoration site, and now the state owns it. So it's just, I hate being negative, but these are just the realities. And so I think that cutting the green tape, figuring out how to align these permit requirements in terms better, figuring out how to work with our local government partners, align plans, and figure out some common goals is really the future that I see. And I think that it's the state's a big part of that. And I want to be a big part of talking to different groups and trying to approach this differently so that we can be on more of the same page at the beginning of a project. But even having those conversations at the beginning of a project doesn't necessarily mean it, streamlines the whole implementation. So I think those are a few of my thoughts, and I'll leave it there for now. Thank you.
Thanks, Charlotte. I appreciate that injection of reality. So we've gotten started on cutting green tape, but there's a long ways to go. And I think the ideas that Britt, the Bay approach to integrating restoration, is another thought. How do we get the agencies to align with each other rather than leaving that to the permittee to figure out? So thank you very much. I want to move on now to Harriet. As a planner, I'm curious if you have thoughts about how the insurance and reinsurance industries could help deal with some of this risk-averse culture. Could they help us by making it okay to fail?
Well, I haven't dealt much with insurance, or reinsurance for that matter, so I'm not sure I can really speak to that per se. But I do think, for restoration to really occur, and kind of jumping upon, your previous questions, it really is about working through and engaging, especially the local governments that have local land use control. And to me, what I've seen, that seems to be the biggest, really the hardest thing to get done in restoration and with climate resiliency and adaptation overall, is that, we have this the big issue with local land use control and the local governments having that control, and then us coming in at the state and trying to do restoration and climate adaptation projects. And there's just a huge push and pull there, and inherent controversy. So that's why I wanted to add to that, but I can't really say too much about insurance, I'm sorry.
No, that's super helpful. It made me think in my head, as the state is handing out the surplus money, maybe local governments should, at least some of them get money for a nature-based solution restoration coordinator. That's what we really need, is somebody who has some expertise in those agencies that we could sit down and talk to, I think, as we're trying to align projects. Does anyone else want to take that insurance question? Okay, I'm going to move back on then to refocusing on, okay, we know there are problems with our current situation, but what would the ideal future look like? And you could tackle this in terms of permitting, planning, or implementing restoration. And I'm just going to throw this wide open. Anybody who wants to answer on our panel, please jump in, because I think we're setting that future vision in our minds so that we can work toward it. Brad.
I could take permitting. Yeah, just a quick note is one of the things that we're trying to do is to consolidate our permits so that a project is not having to go to different parts of CDFW or different people at CDFW. And ultimately the goal would be to have one, so-called master permit, which would include lake and stream alteration if that applies, any take authorizations for the project, or anything else that's needed for the project. And again, that's through the entire lifetime, from initial construction and operations, maintenance, and monitoring. So that's one thing that's on our radar, is a really important priority to start working on the alternatives, given the legal framework and everything else. But how do we do that? And then just really quickly to respond to Charlotte, you are so right about varying conditions of approval for permits. That's another big priority for us, is to really look at other agency permits and see where we can use either the same terms and conditions or collaborate on them. And that's one of the reasons why that Redwoods Rising project, even though it's so large, that permit was only 18 pages. We used the park's own CEQA documents, we used the federal take authorizations, and didn't, we ourselves weren't terribly creative. We basically recycled those conditions for that purpose, so that when that project is done, it's more straightforward and easier to understand for the permittee.
Well, that's great. Recycling is good. I like that idea, Brad. Jeff.
So, so much of our discussion today is focused on land and not enough on water. And until we can integrate the way we manage water with the efforts to restore land, I think we're stuck. And that's why for the last 5 years at PPIC, we've been promoting this notion of an ecosystem trustee who would manage an environmental water budget. And that budget would be specifically paired to actions on the ground. So I think until we link those two together, we're not going to be ultimately successful, particularly at scale. So I would like very much for the state board to be much more aggressive about its approach to the land, not just the water, not just flow and water quality, but the land that it runs across. And I think that's going to be key. So there's where I think we might get a breakthrough down the line if we can try and do something like that.
Yeah, State Water Board, you have more power than you're exerting, perhaps. I don't know, Christina, I don't want to put you on the spot. Do you want to say anything about that?
I mean, yeah, I wish we had land use authority, but we don't. So, or at least at the, mind you, I'm at the regional board, I'm not at the state board, but yeah, I mean, this is one of the challenges with, a lot of it's a broader governance issue. It's not just a permitting, a regulatory issue, in the downstream, in the lower estuary, BCDC has land use authority, and then we have jurisdiction over water quality, and then CDFW has jurisdiction over species. We also have beneficial uses for species. It's a tough challenge, and I'm a wetland restoration engineer. I'm not an expert in aligning government administrative processes, but I think unless we begin to tackle that and tackle that land ownership issue, because that land issue has a direct tie into the water issue that Jeff just mentioned. Both Charlotte and Jeff have echoed that. I really think we're going to continue to struggle unless we figure out how to get bigger properties, and I think the work that like Sempervirens Fund and Save the Redwood Leagues that they're doing to support state agencies like parks in the Redwoods and in the Sierra Nevada, those kinds of nonprofits, I think that's an interesting model. And I think we should look at that model and think about how we might be able to tweak portions of it to apply it to the estuary. Because I think that might be a way of getting at the challenges of this land ownership and what that land ownership means for water use.
Could you summarize how that model works in a couple of sentences?
Oh gosh, it's basically how nonprofits are supporting land acquisition and management in the absence of state funding for land acquisition and management to support ecosystem services on land that's owned both by the state and by other partners. And we don't really have an entity like that working in the estuary. We basically have publicly held lands and we have privately held lands, and there isn't really anything in the middle. And that could be an important way of getting at these challenges of land ownership.
Thank you. There was an interesting idea that just popped into the chat. Could permitting be restructured so that they can easily be reissued within a 5, 10, or 15-year period to address adaptive management and failures? And so it's sort of like, it's not doing be all and end all permits, but making it a bit of a lighter lift so that relatively soon we could adjust them as needed. And everyone, I think this is one of our huge challenges as just like Homo sapiens, we're not good at this, but also our own culture here in California. We want stuff to be for sure and forever, and we want these full-on guarantees. That is actually not how life works, and it's certainly not how ecosystems work. So what do we think about thinking differently about the timeline of permits or the frequency of permitting? I'm just throwing it open.
Short answer is yes. And again, just going back to our new permit, we have made it very easy to amend, very easy to renew, and we're permitting at this point a 30-year project. And in the Redwoods Rising example, we're using the term of the permit itself is 15 years, but it's a nearly automatic renewal, and you can also take that opportunity to incorporate tweaks if they're needed. So that was, that was our goal for that new permit type, and we're hoping that we can adapt it to others. Some permits have built-in, maximum terms and things like that gets into the legal world, but from a practical standpoint, I think that is really needed.
Thanks,
Yeah,
Brett.
I'll just add that a lot of state, so the water board, we already issue, we have the ability to issue permits on longer timelines. The Army Corps, those permits are generally, they have a 5-year window. Maybe with the upcoming Supreme Court ruling, that won't matter anymore. We're just going to have no federal protections for waters. Again, that's kind of gets at this conflict between their state permitting processes, which those of us here on this panel have the ability to align, but we don't have the ability to align the federal permitting processes. So we really do have to work with our federal partners. And that's something that the BRIT, I think, is illustrating how we can do that.
Thank you, everyone. This has been such a great chat. I feel like, I don't know, if we could just implement all these great ideas faster, we would get there. So thank you so much for all your work. I especially want to say everybody who works in permitting and putting in projects on the ground in real life, thank you so much. It seems like such a hard job, and we're all grateful. All the living things in California appreciate you. And I'm going to hand it back over to Dylan because I think we're on time for our next section.
Yeah, thanks so much to everyone on this panel. Super engaging conversation. Really thankful to have you all here discussing this, and just want to echo Letitia's thanks to the folks on the ground, both putting in the projects and helping to address some of these permitting issues as we move these forward. And Christina Toms also put something in the chat mentioning that staffing at state agencies is a huge challenge, and that more staff with appropriate technical qualifications that are in permanent positions that can really have long-term arcs with these issues is really important. And I think, thankfully, it seems like, Brad mentioned that the Green Tape Initiative is certainly growing. And so I do hope we continue to see this trend that's linked to some of these big, large-scale goals that the state has around biodiversity and climate change, them continuing to put their money where their mouth is, so to speak, around actually supporting staff and, supervisory level positions to tackle these really complex projects. So thanks again. And with that, I would like to bring us back to Laura Larson, who we started with at the top of our symposium. Laura is our lead scientist here in the Delta Science program, as well as a professor at UC Berkeley in the geography department. And she is going to lead us through our final panel here, which will be bringing in perspectives from our various speakers, panelists, and moderators so far, as well as Laura leading a recap of some of the things that we've seen presented so far to help us start to think about the next steps. So take it away, Laura.
Thank you, Dylan. And wow, it has been such an honor to both open and close what has been a truly inspirational symposium. Letitia Grenier made a statement earlier today about how we're all essentially saying the same thing about where we need to go to create a sustainable watershed in the face of climate change. And I too have observed remarkable convergence across this symposium. And this final session of the symposium gives us an opportunity to recognize and discuss that convergence. So as Dylan said, I'm going to kick the session off with a brief summary and a recap of the thematic deep dives that we've done in the individual sessions over the past 2 days. And then I'm going to moderate a broad scale discussion with all of the previous panelists who are still with us today. And I'd like to encourage the audience to keep dropping questions into the mural and voting for questions that are already there related to this prompt of how we might move forward as a community under uncertainty. Next slide, please. So we started out this symposium with the question of how can we adapt ecological restoration for a changing climate? Next slide. And this leads to additional key questions, such as what are the futures that we want to see for ecosystem restoration? And then how do we get there as a community of practice? Next slide. So these questions were really motivated by 3 goals in this symposium. And the first goal that we saw was to foster information sharing about climate adaptive restoration across a variety of projects and ecosystem types. And speaking to that goal specifically, we heard talks about the restoration of wet meadows way up in the watershed, all the way down to restoring seagrasses in the offshore environments. We heard discussion about how creative, innovative projects like floating marshes could help reverse deeply subsided islands in the Delta. And we also learned about how to preserve existing ecosystems using more traditional techniques, such as sediment augmentation. Related to the second goal of creating and enabling an environment around climate adaptive restoration by connecting decision makers, practitioners, stakeholders, and scientists, we heard a lot about how this goal really involves changing our paradigm about who is involved in science and how information is presented and shared. For example, we heard transformative and disruptive talks, and I use disruptive in the best possible sense here, by Karina Gould and Obi Kaufman on day 1. And then adding to those, today we heard from Nahal about the role that art is playing in the environmental justice movement. We heard about how Michelle Stevens is bridging many boundaries in her work at San Francisco State, boundaries between science and practice, between Western and traditional knowledge. Similarly, we heard about the transformative work of the Oakland Shoreline Leadership Academy. And we heard again and again about the utmost importance of constantly communicating, which includes not just talking, but also, and perhaps more importantly, listening. We also heard about how compensation for community organizers and participants can be essential in enhancing inclusivity in science-based planning. Then the third goal of this meeting was really structured around strategizing about how restoration can be adapted to a changing climate and include long-term planning horizons. And speaking to that goal, we heard about the importance of holistic planning that considers the watershed from its headwaters to the coast. And by holistic planning, I'm really speaking about planning that optimizes multiple benefits. We heard discussions about long-term sediment planning horizons for the survival of marshes in the bay's coastal areas, as well as about the importance of coordinating that long-term planning for sediment across the Bay Delta interface. We considered creative strategies for reversing long-term subsidence and how we might move toward reestablishment of the Delta as a long-term carbon sink in global carbon cycles. And finally, we heard about tools that facilitate the process of participatory scenario development using tools such as the Delta Landscape Scenario Planning tool. Now, I'm going to bring your attention back to how those goals were manifest across the individual sessions, starting with the next slide. So on day 1, the first session was adapting restoration, was restoration and management across time in a changing climate. And so we heard really inspiring talks by Karina Gould and Obi Kaufman. And this graphic just reminds us of the historic tribal management of different areas of the state. I should say stewardship rather than management here. Next slide. Then we transitioned into a session on adapting restoration, where we considered numerous on-the-ground examples, including Bushy Lake here in Sacramento, Elkhorn Slough. We heard about horizontal levees, and this was a really good example of how adaptive management could be used to troubleshoot failures, in this case, troubleshooting wave erosion using eucalyptus logs. We also heard about shoreline resilience in the Bay and floating marshes in the Delta. We heard about sediment augmentation. Next slide. And then the third and final session of yesterday was focused on partnerships for restoration and management, where we heard phrases like just keep talking. And we heard about the importance of compensation for community organizers and participants. This photo is from the talk on the Oakland Shoreline Leadership Academy. And there was a lot of really good discussion in this session about the importance of cultivating a connection between residents of this landscape and nature. Today, Amy Merrill talked about restoring people's connections to rivers and just how important that was. And Scott Dusterhoff talked about the importance of getting people engaged and excited about baylands and how critical this is for not just for funding the science and the implementation, but for really motivating people to care about the importance of this landscape, and in particular, its importance in regulating nearly every aspect of our modern lives. Next slide. Today, we kicked off the morning with a session on linking long-term perspectives across the San Francisco Estuary and its watershed. John Calloway talked extensively, and the speakers in the session talked extensively about the theme of connectivity, complexity, interdisciplinary thinking. And when we're talking about connectivity, we're talking about connectivity for water, sediment, fish, and also processes. Connectivity is a concept that has multiple dimensions. And in this session, we also returned to some discussion of the importance of the connectivity of people to the land, starting with kids, the importance of telling simple stories about the land that really have the potential to motivate action. We heard from Jacob Katz on how a working river ecosystem is the best investment for a healthy bay delta, and about how landscape scale projects have the potential to really move the needle here. We talked about the importance of walking while chewing gum. There's this urgent need to begin the implementation phase while continuing to learn more about our system. And I would say the umbrella theme of this session was really working through how to optimize multiple benefits at a landscape scale. And one great example of that is the example of riparian managed aquifer recharge. And then next slide, please. We just had an excellent session on visioning the future through permitting, planning, and implementing restoration. There was a lot of discussion in this session about nature-based solutions and restoring natural processes. Letitia further described this as taking advantage of flood, fires, and flows to put ecosystems back together. We heard about cutting the green tape and redwoods rising. We heard about the Wetlands Regional Monitoring Program, which is a great example of how to enact this need we have to bridge the Bay Delta jurisdictional boundary and move away from project-specific monitoring to monitoring that fulfills multiple needs at a landscape scale. We talked a lot about how to align projects and the idea that maybe the state needs a nature-based solutions restoration coordinator came up. And this slide, of course, that I'm showing on this, or this graphic that I'm showing on this slide shows the Eco Restore projects. So next slide. Next slide, you can move ahead. So this brings us to the topic of this session, which is moving forward under uncertainty. And in today's discussion, I really want us to explore the overarching question of how can we synthesize information, incorporate a broad knowledge base, and build shared understanding to adapt restoration for climate change. That's a really broad question. So I'm going to tackle this by breaking it up into more discrete questions for the panelists. So at this point, let's end the slide sharing, Beck, and I would invite the panelists who are present to turn on their cameras and either use the raise hand function or just jump in when you feel compelled to answer any of these questions. And the first question that I'm going to pose to you is really focused on opportunities. We started out this symposium by talking about how it's really easy to feel down when we consider everything that climate change is bringing our way over the next decades, and to feel down just about the general state of the world. But I think there were just so many motivational talks about how hopeful restoration is. And at the end of the last session, Letitia said, you know, I think we could really get there if we come together and start acting now. So I want this question to really focus on what the positive news is. Where are there opportunities for us to make progress in planning in the near future and beyond? Let me open up the floor with that question.
I'll dive in, Laurel. I think in our group, everyone highlighted we are making progress in a lot of ways, and it's really building on what we're doing now, and as everyone has said, trying to really increase the speed and the scale at which we're doing things, and sort of simultaneously improving the communication and the collaboration across groups and across agencies, while we also are sort of tackling these projects and just try to speed things up as much as possible.
Yeah, I think that message came across loud and clear. Maybe to provide a finer focal point on this question, one of the things I'm really interested in hearing from the panelists about are, as we move forward, we're considering a landscape that's going to be nothing like what we've ever seen in this area before. We're facing a new set of climate forces that are going to cause a transformation of this landscape, hopefully a transformation in a direction that we would consider to be sustainable. But in this ecologically novel landscape that we're facing, what are some of the ecological functions that we should really be emphasizing in our actions? One of the themes that's been discussed a lot at this meeting is ecosystem services and ecological functions. So I would ask this panel, what are the specific ecological functions that we should be emphasizing that help us to more effectively work with nature?
I want to jump in as the sort of biologist who knows the least about this, and others can add, but I feel like I almost never think about monitoring wildlife anymore, which is really what I'm trained in. We need basic fundamental physical processes, especially in the Delta. It's what we're lacking. And I do see a lot of great leadership coming out of academia and PPIC around this, which is like, how are we going to do these functional flows? Like, how are we practically going to make our hydrograph work? Without that, we're like trimming the tips of the tree without that. Like, we need to be supporting the trunk of this tree. That's what creates and maintains the physical landforms that can then grow the plants and animals and all the other functions that we're interested in. So I think this idea of I'm not going to say it right, Jeff, you can jump in, but as like a trustee for the environment that controls water for the environment, this is a critical idea. Why isn't the environment as important as any other water holder? The environment is all of us who aren't water holders, like me and my kids and you and your kids, you know what I mean? So how can maybe we need to like change the wording on that so that it's clear that that's like the public good. It's not like some creature that nobody cares about who lives in a city. It's like all of us need that environmental water. So maybe some of this is about how do we rebrand that? How do we rebrand the way we're thinking about this so it doesn't seem so jargony and so that we realize it's fundamental to our own well-being?
Yeah, I think that speaks really nicely to the need to tell the story more effectively and to, package it as a story. You mentioned Jeff. Jeff, I wonder if you want to jump in here.
I know I'm being uncharacteristically quiet, or at least those who've worked with me. I also want to point out, you've got Sarah Yarnell here on this as well, and who's one of really sort of the big thinkers on this notion of functional flows. But Laura, at PPIC over the last 10 years, what has really become evident is we're stuck in and no offense to the state board, kind of the in-stream flow and water quality model. That was, we set a series of standards. Everybody works toward that standard. And one of my complaints about that approach is, first of all, it adds to this unvarying condition, this flatline hydrograph, which is something that Sarah Yarnell has produced, written some really beautiful articles about how much trouble that is. But it makes the environment, and this goes on Letitia, it makes the environment a constraint rather than a partner in water management. And I think that is probably the most fundamental change we can make, is to start to think of the environment, and this is where the multi-benefit projects come in, where the environment is a partner in it. And of course, Letitia is an author on it, and so is Sarah. You got 3 authors on one that said the way to do this is to grant the environment a water right. Give it a water right, or at least the equivalent of a water right, because if we don't create flexibility in how we manage these systems, I am certain that we will see climate change create a train wreck when we're stuck in, when's the last time we updated our water quality control plan for the Delta? It was 1995. And so we've learned a lot, and we still don't do it. So we need some flexibility in the system, and we need to make the environment a partner in the system rather than a constraint. I think that builds on Letitia's. Again, you've got Sarah here. She's the expert on all of this.
Sarah, would you like to comment?
Well, I'll comment, but I will say I'm definitely not the expert. Like, one thing that does get lost is there is a large group of collaborators and scientists working on these ideas throughout the state. So, you know, and it's this collective discussion that has really, I think, helped to move these ideas forward, right? So 2 comments. I 100% agree with Jeff and Letitia that, you know, once we bring the environment to the table as an equal stakeholder, it allows so many opportunities to truly be able to implement a lot of these multi-benefit projects, right? So this idea of saying that when we release a pulse flow, where does it go? When do we release it? How many multiple benefits can we get from it in a way that really is maximizing what we can do with that pulse, with that amount of water at that time? And politically, I mean, and again, I'm the scientist, right? I'm coming from the more technical side, but it really does seem like allowing, you know, having an environmental water budget, having a trustee, it provides so much flexibility that we don't currently have in a lot of our policies. If you have a budget, everybody else is certain how much water then is going to be allocated and what they can do with it. And then we have the flexibility to change and manage that budget, try step out, make mistakes, monitor it, learn from it, and really, it's like one of the best ways to adaptively manage. How can you change if you don't have the flexibility to change or be able to respond? So just wanted to agree and point that out. I also was going to make a comment going back to your original question, Laurel, about this idea of monitoring functions, or how do we define functions? And that's a really interesting point of discussion that as we move forward with thinking about how do we implement functional flows, how do we do this on the ground, how do we quantify it? There's been a lot of great discussion about that and a lot of research that's starting to come out. I'll make a plug for, there's a special issue in Frontiers in the Environment, Freshwater Science. It's an open journal, open science journal. And there's a whole series of papers in there about environmental flows, a lot of examples from Australia where they have these environmental budgets that they manage on a regular basis. It provides great lessons for us in California, and a lot of new papers about different ideas and different ways that we could implement floodplain restoration and implement these environmental flows. And how do we quantify these in a way that's measurable? So if we're doing our monitoring, we're going to do our practice, we're going to go make a bunch of mistakes, we all have to be able to put numbers on it, right? And so how do we go about doing that? And I'll put a link in the chat, and I'll stop there.
Well, thanks for that. And we'll make sure that meeting participants get that link. It sounds like a really great resource. This conversation about partnering with nature and functional flows reminds me of a similar conversation that I've been party to in Northern California. There's an idea of partnering with beavers in order to enhance exchange with floodplains and residence time within river corridors. And that just reminds me of all the great conversation we had earlier today about residence time, and how that is one thing that we could be monitoring as a metric that's indicative of so many ecological functions here, and a metric of connectivity as well. Any further thoughts on that, John?
Yeah, I was just going to add, Laurel, I think in terms of biological side, I would put in a strong plug for just focusing on productivity overall as a key component, and and thinking about productivity within different components of the ecosystem, aquatic productivity within the floodplains and everything. And then of course, biodiversity. But to me, productivity, especially with the food web issues, would be something that, that we are monitoring in some places, but we really don't have a good comprehensive understanding across the system. I know there has been a lot of work recently to look at current and historic productivity in the Delta and the Estuary, but I just think that's something that we should really key in on. In addition, I mean, of course, the physical issues are critical.
Yeah, great point. Thanks for pointing that out. Lisa Marie, I'm going to pass it to you because you talked a lot about blue carbon, and to me that it seems like there could be additional functions related to carbon storage in the Delta that we monitor, and just wondering what your take on this question is.
Sorry, the take on, can you just repeat the question? So
the question is, what are the ecological functions that should be emphasized in this novel environment? And we had some discussion about what should be monitored associated with those ecological functions.
Yeah, well, so residence time to me, frankly, is a huge part of carbon sequestration. So, and the geomorphology really is what sets the tone for what's capable of being restored. I'm interested in the floating marsh concept, but I'm not sure it has, I don't know about the long-term sink, because so much of that has to do with anoxic settings. So I'm interested, it's no question. But we have to follow that productivity chain all the way through to the old carbon, and then how well it's, you know, stored there. And I know that there's some concern about whether we can ever fill that bowl again. To me, again, it's a question of will, and you know, and effort put in. I still think that the potential exists. So, you know, within reason, I think we're gonna have to prioritize some areas over others. But regardless, the blue carbon aspect, the potential is it's so big in San Francisco Bay. We're really poised well. We have high productivity. We have you know, these great low temperatures because of the delta breeze at night. We have a lot of capability of storage of that carbon across the whole system. And so again, resilience of it with sediments are critical to keeping it there. But the potential for San Francisco Bay, I'm just thinking about the whole world, some of our really good spots. It's one of the hot spots. So it would be nice to see that prioritized.
And I might just add on to that I would encourage all of us working on projects, even if that restoration project isn't focused on blue carbon and it seems like an overwhelming topic, there are ways to partner and include a component, even if it's a few sediment cores, not to downplay the work that's involved with analyzing and planning for blue carbon with sediment cores, but you know, an example with our giant marsh living shorelines project in Richmond, oyster and eelgrass beds and other habitat strategies. But Kathy Boyer and Karina Nielsen have been able to bring in OPC funding to look at blue carbon interactions and do some sediment coring at that site. So I'm so thrilled to hear the sense of urgency from all of our colleagues, the sense of experimentation and allowing for that. And I really encourage each of us to step outside of our direct project goals and think of ways that we might still add in some other benefits or monitoring.
Thanks for that addition. And I would just say that, you know, one component of trying to address these really holistic goals using innovative strategies is we are going to see failure. There's been a lot of conversation about failure today and some of the opportunities presented by failure. But there's a question that has been posted to the mural, which I think is an interesting one for this panel to consider, which is, what does failure mean and how can we build a culture around recognition of failure as part of the process? And how do we learn from it and use it? So this, you know, I think speaks directly to some of Sarah Yarnell's and John Calloway's earlier comments about how we need to be able to learn from failure, and we need to monitor our actions in order to learn from failure. Letitia had a great comment earlier as well about how scientists in New Zealand have to talk about how their work might fail in order to get funding. But you know, there's a really interesting follow-up question too for the panel that we just had. What does failure mean specifically in the permitting process? So let's just consider this notion of failure as a group for a few more minutes.
Can I tackle that briefly?
Yeah.
As the Eagles fan steeped in failure and some I think one of the things we need to be really honest with ourselves about, what do we mean when we mean failure? Is it a failure if we're trying to accelerate the pace of restoration in the estuary, right? Is it a failure if we restore a wetland that is able to persist for 20 years, but isn't able to make it into a 50 or 100 year timescale? If that wetland provides a bridge to other wetlands that are in a landscape position where they're more likely to persist for a longer period of time. So I think we think of failure as a binary, as something either succeeds or it fails. And I feel like there's a lot of struggle in the lower estuary with coming to terms with with the potential for failure, and a reluctance to admit that maybe not all of our wetlands are gonna make it. And I think particularly in the more urbanized parts of the estuary, we've got some real challenges with how we're gonna maintain wetlands. And it may be that there's some wetlands that we decide they're worth investing in to artificially maintain through targeted sediment placement or other processes. But I'd really like to think that, and this is why I think the Highway 37 is really interesting, because that Highway 37 is at the edge of the estuary. It's at a part of the estuary that's retreating, that is subject to tidal action, but also wave action and flood inundation from the watersheds on varying scales of space and time. And so like figuring out, how do we build bridges between the mature tidal wetlands that largely exist in the Centennial Marsh at the edge of the estuary, and be able to build bridges for them to get back farther up into the canyons, upslope into the estuarine terrestrial transition zones? That's what we should, and if we fail, if the outer wetlands fail to maintain themselves, I think that's okay. I think that's a reasonable way to look at it, as long as we're giving them the space on the longer time scale. So I'd love to see that incorporated more into decision making and more into kind of these impact and mitigation decisions and risk management decisions.
I really like that. Oh, go ahead, Letitia.
Can I build on that a little bit? Because I think something Jacob put in the chat was really relevant here. We've got to change our expectation around what the goal of restoration is. We're not trying to restore X acres of this kind of habitat type for this kind of species. We're trying to create certain functions on the landscape for a certain amount of time that lead us on our adaptation pathway. And maybe we have to say, and even if we don't get all those functions, but we just learned something, we still didn't fail. If people can't handle the idea of failure, which is fine, we just need to realize we have to readjust our expectations. I think that's really hard. Some of these acreage goals have been written into policy and funding objectives and things like that. But what we really want to say is we want to use natural processes to create and maintain landforms that can then support habitats and functions that we're interested in. Super jargony, so got to work on the story. I get that. But that's really what we want to do. And we're not in a static world, and we kind of faked ourselves into that for a couple hundred years, but it was never true. And that's like maybe we need some psychologists. We also need to really have help with adjusting our expectations and then writing that into our policies and our funding vehicles and all of those kinds of things.
And thanks, really appreciating all these perspectives. I also did just want to make sure we weren't leaving behind some of the ecocultural perspectives that we heard, particularly throughout day one. And I do want to acknowledge that one of the challenges with thinking about, not necessarily wanting to have a species focus is that, as we heard from Karina Gould, as we heard from Michelle Stevens, and as we heard from Don Hankins, from an ecocultural perspective and an indigenous perspective, often those specific species do have really particular cultural relevance. And so I think it's also, as we think about these shifting landscapes, I think it's also really critical for us to not lose sight of how can we continue to make more space for underrepresented perspectives, and really thinking about how we can make that engagement. And so from the perspective of that, so if we do have, for example, a freshwater tule wetland that does get drowned by sea level rise, how can we work to make sure that any ecocultural uses of that site can be maintained, that not just the ecosystem itself, but those uses can then be transferred to other parts of the landscape? And I think that that's a whole other piece that we're really behind on, frankly, just to speak very clearly here. And I think there does seem to be quite a bit of forward momentum on this now, but reestablishing more of that indigenous connection with the landscape, I think, is just also something we really need to be thinking about proactively in the context of these conversations we're having about changes. How can we facilitate that continuing to grow access, thinking about concepts like land back, like we've mentioned on day one, with that recent example from the Sinkyoni Council, those 500 acres up in Redwood Country. How can we start to bring more of that to the estuary? I think is really important for us as we think about long-term timescales.
I really appreciate that perspective, Dylan. And I think it is a nice lead in to another question that I wanted this panel to consider, which is how can we work to incorporate a broader knowledge set into planning and implementation of restoration? Any takers for that one?
I'll just note one example. We're proud of a grant program the Coastal Conservancy started with Marin County, the Marin Community Foundation. It's just one model, but it's a great example of working together to encourage nature-based adaptation, design innovation, pilot projects, seed funding that specifically encourages underserved community engagement with the direct communities that are most impacted, like the San Rafael Canal community, the Marin City community, and others. So I would love to see that type of model where funders and planners at the county level are encouraging and really providing support for those partnerships and those relationships to develop. And we're just in process on working to evaluate those starting steps and learn from, how we can better communicate between ecologists and, culturally relevant engagement with the direct communities.
And picking up on a really important point that Phoenix Armenta made yesterday, a big piece of that is figuring out how to pay communities for their involvement. All of us on this panel here, we are paid to be here. And that's a really critical piece of why we can show up. It's part of our jobs, and the ways that we have structured to pay community members are, have not caught up to kind of the science on the positive impact of using that as a mechanism to bring communities into the conversation. I think it's obviously having public meetings, opening those things up, really important, but until we are actually helping to address some of those, equity and equality concerns also that Nahal had those really great illustrations of in her talk today, it's going to be really challenging to meet that. So just to bring back a few of those perspectives from panelists who weren't able to join for this last session, but brought up some really important points on that topic.
And Dylan, just really quickly, in addition to compensation, having childcare meetings at night, paid participation, that really leads into workforce development, having job opportunities, having direct engagement, and the ability to participate in the green economy and green infrastructure. So yeah, I think there's some really exciting work. The Ecological Workforce Initiative and others are trying to work with labor boards and, local community job opportunities. I think would be great to bring into the discussion.
I think I would be a proponent of something more transformational like watershed councils, where we had communities sitting on them. We had these long-term relationships between local government, scientists, NGOs, and different levels of government and communities. So that I just think it's really hard to have engagement on projects that doesn't create enough of a relationship, and it doesn't give the communities enough power and say in how their values and priorities are implemented. Sarah just said watersheds are socio-ecological systems, and I think that's right. We should be getting together as different types of communities at the watershed scale to plan how we want our ecosystems to work. And I think one thing that maybe hasn't been said with regard to DEIJ issues around environmental work is that it's not just when I did the tiny bit of research on this, I found there was a little bit of study of who pays the price of the choices we make environmentally, but we haven't looked at who benefits. And the few studies who've started to look at who benefits from restoration it's hugely also unequal, and unjust. So we actually need to be bringing, I'm not sure we flipped the lens that way. So as we're doing restoration, we need to be quantifying that and thinking about that more, and having our communities, our BIPOC communities and other frontline communities with an equal seat at the table from day one, with power and money behind it, and not just being asked for their advice.
I think that's a really useful response, Letitia, and it kind of brings us back full circle to where we started talking about ecosystem functions and services that we'd like to measure. And it's important to remember that these ecosystem functions are also human in nature. And it's really important to measure outcomes for human communities and how those outcomes influence issues related to environmental justice. One of the other things that I think is a really nice connector in what you just said was you mentioned how building a more inclusive environment can help us to better work across the watershed scale. And that leads really nicely into what will probably be the final question for this panel today, which is, it's a question from the mural, and it's how can we work better across silos to coordinate activities that would benefit restoration? For example, how can we plan wetland restoration to benefit from flows containing sediment released for agricultural and water exports? And if there are knobs in the system that we can use, we need to know exactly what they are and how we can use them productively. So big picture question, how can we work better across silos to coordinate at these larger scales?
I'll just jump in with the one example I have that I'm involved in, and I'm sure there's others out there, but and I mentioned it earlier, but the Water Quality Monitoring Council is the regulatory group that actually sits above, right, Cali PA. And so kind of once we sort of figured out, here's a place where agencies are allowed to come together to talk and meet, just like they do for the swamp program and some of the biomonitoring programs. It sort of allowed us to, still took about a year or so, but allowed us to have an opportunity to create a space for agency folks to come together and for the public to come and join those meetings. I'm not saying that's the only way to go. I'm sure there's a lot of others, but it's just one example of trying to find, these places and locations where people in their jobs have the capacity to be able to come together and meet. So one example.
That's great. And Christina, I'd pass it to you too, because I think the Wetland Regional Monitoring Program is a great example of how we might better coordinate across agencies and jurisdictions that are typically siloed.
Thanks. Yeah, I'm glad you brought that up. I mean, I think both our steering committee and our technical advisory committee represent a really broad range of stakeholders and perspectives and experiences. And, the program, we're building it very gradually. So, it's getting off the ground slowly. But I think one of the things that we've already been able to demonstrate with these groups is the utility of having all these folks together and engaged. And at least in the technical advisory committee, we've had USGS come to us with looking to us for input for projects that they're working on that aren't necessarily WRMP projects, but they're projects where their indicators and their methods are aligned with what the WRMP is trying to develop. We've been able to help the Army Corps identify how they could use their in lieu fees, money that they weren't able to spend monitoring the impacts of their dredging operations on fish communities, and be able to use some of that money to figure out how dredging benefits fish communities, beneficial reuse of dredge material benefits fish communities. So just as a forum for collaboration and transdisciplinary thought, I think it's really demonstrated its utility. And so I'm really excited to see what we can do now that we've got new funding from the Restoration Authority to actually begin to implement our broader science framework.
Great.
I have to plug Letitia because she does a lousy job of doing it for herself. I just posted to the chat a report she did last year, which took a look at basically smarter permitting. And underneath that smarter permitting was this creation of collaboration between multiple agencies that might never even talk to each other. And she's got some really good case studies. My favorite remains the Upper Santa Ana Watershed and the HCP they put together there. So this is where so I'm actually a big fan of using regulatory mechanisms to combine people together, not just the agencies, but all the stakeholders as well, under a unified vision for what to do. So I really recommend taking a look at that. And again, Letitia never tweets her own horn, but I recommend taking a look at that one.
One other thing. Oh, go ahead.
Can I just add a super quick thought, which is that, this is all about leadership, what Jeff talked about. These examples of smarter permitting really are about individuals taking the lead and being given the freedom to do so by their superiors in whatever organization it is. And I think we should hire Heather Dyer, who Jeff is talking about, and she should set up a program for the state of smarter permitting. It doesn't need to be super hard. I think we can take advantage of those great leaders who we have.
Laura, can I add one more example?
Go ahead.
The YOLO Cash partnership, which we have to sort of help provide better communication about restoration and other flood plans within the Yolo bypass and the Cashley region. And so that has federal, state, local, and down to reclamation districts sitting on one group. And I'd say that there's just such a power in just having one single map where we all put our planned projects or objectives and sort of think through the timelines of those. We make a commitment to each other through an MOU where, you know, if we have projects in that area, we bring them to the table and talk about them in that sort of group, and that sort of commitment to break down the silos and have, you know, better communication across those different agencies. It's been a really powerful thing. And one of the things that has come out of that is now we're working on a habitat conservation plan for the area to help provide coverage to agricultural diversions, which is one of the key, you know, resistance to restoration in that area is you know, what's going to happen to agriculture and diverters in the area when there's more endangered fish. And so we're trying to work through that as a group. And so I think that that could be a model for other areas within the state, within the Central Valley, of how to get, you know, a lot of different agencies, the Army Corps of Engineers, U.S. Fish and Wildlife Service, NIMS, you know, these groups that are at the federal level, sometimes hard to coordinate with, talking with the state, down to the counties, down to even, you know, like I mentioned, reclamation districts on the ground. And so it's been a great partnership, and I hope that we can do more of that going forward.
That's a really hopeful note on which to end this panel discussion. And I'll say I love this mixture of both aspirational and practical suggestions that have come out of this conversation and the broader conversation that we've had over the course of this 2-day symposium. And just related to this last question of working across silos, we heard this morning about this idea of moving sediment from the Yuba River floodplain all the way down to marshlands in the Bay, which I would characterize as aspirational at this point. But then in this session, we heard about practical ways to go about tackling these challenges that require large-scale coordination, including addressing permitting, making a map, having the right leaders in place. So I just really appreciate all of your thoughts. So many great ideas here. And thank you for joining me today for this panel. I'm now going to turn it over to Dylan, who will close out the symposium.
All right, well, just to echo Laurel's thanks, and, you know, we are right here at time. So I, you know, just want to, again, extend a huge thanks. And we had a question about this closing panel that I just also wanted to answer, just some curiosity around who was represented. And this was open to all speakers and panelists, but some of them had timing conflicts. And so, so the folks that we saw represented here were folks who didn't have timing conflicts for this closing panel. Just wanted to make that really clear. And so, you know, we've heard a lot, and there were tons of questions that we didn't have a chance to answer in this limited time. And so I do encourage you to keep an eye out. If you registered for the symposium, you are on our list, and we'll be following up with videos of the symposium, as well as some follow-up materials. And the mural will stay open, the mural board. And so that, that information will also recirculate to the full email list. And with that, I think I will officially adjourn our symposium today and extend a big thank you to all participants. If you do have any follow-up thoughts, you can use this hashtag adapting restoration hashtag on your social media. And of course, always feel free to reach out to those of us at the council, myself and Jenica, who have been planning with any follow-up questions or thoughts. We wish you all well. And again, just really appreciate you all taking the time to think through this, contribute your great questions. And thank you all for the work that you're doing on this topic.